So I don't know if you are aware of this, but it has been a hot second. But I'm back for once. Who knows how regular I'll be? If you know me personally, you'll know regularity is not particularly my strong suit. But we're back. What I have going on today, I think, and pre-apologies because I didn't mention this on Discord that I was going to go live or anything, because I figured, why disappoint people again? Because I let people on Discord know that I was going to be online 2 weekends ago and then never got online. So, but on this day, what I'm thinking, I believe I was talking about this last time. I don't remember. Doesn't matter. I can't remember exactly what I did last time. But I was saying in general, finally have some kind of host interface so that I can poop code onto the NES without having to reburn EEPROMs a bajillion times. And this is also spurred on by the fact that on my 6502 tutor boards that I've been building, which that's a whole other project. I won't mention it so much this time because last time I did a lot of talking about the 6502 tutor. But it is a very simple 6502 CPU tutor board, and it does Bitbang serial. Stephen Wright says, just bopping in, good luck tonight. Thank you, Stephen. Good to see you. Anyhow, does Bitbang serial over like an FTDI-ish thing, because I figured I wanted to keep it as simple as possible. So I realized I should just be able to do the same thing with this. And what I was thinking, at first I was like, okay, the mapper chip, my my glue logic PLD here that I've been using, and make like a 1-bit input on it, because that should be all I need. I don't want to transmit information to the PC. I just want a channel over which I can quickly stream bytes over, so I can chuck it in memory and then start executing. And then I realized I don't think it's that complicated, because there is the disk change / disk presence pin on the floppy controller. And I can't. I'll have to get creative about that when the floppy's plugged in. Maybe just like cut that pin on the cable or something if I want to keep using this. But if it really is just like a transparent, when you read from the register that has that bit in it, I think it literally just enables bus transceivers that take those pins and route them to the data bus. So I think I can read that as fast as I want. Though I've never really had a speed issue reading or writing from the FDC anyway. It's made to handle much faster bus speed, so I don't know why I'd even be worried about that. But anyway, so use that as my TTL RX pin, attach that to an FTDI, which I actually have sitting over here, that I need to steal. Forgot to do that before the stream. And I already have a Bitbang serial routine, not that that's complicated, but I have one for my trader boards that I'm building. So I'm just going to steal that and slap it on here, and today hopefully we'll be able to string some code over, boot over serial, and use that to more quickly write code. I was also thinking in the back of my head, I have no idea if I'll get to it today, because I'm assuming I'll have enough time to get Bitbang serial working for downloading code, but I'm also thinking, just for fun, I don't know if fun's the right word, about switching to using C for the floppy crap. I mean, just for all the crap, but because why not? I'm using CA65/CC65, which is a C compiler for 6502. So if I already have stuff more or less set up, why not just write it in C, and then hopefully my mind won't be quite as burnt out trying to do these floppy routines, especially with all the retry logic. So that's a thought too. But today I'm thinking, let's do the Bitbang serial download, and I think that's a moderate goal. Really interesting. I mean, my level looks okay. At least in the... Oh, wait. I know what it is. I think. Maybe. No. Wait. Okay, I do see it peaking, I think. Hold up. Hold up. Okay, that. Wait, no. Man, that's weird. Why are you peeking so much? Why are you peeking so much? Hold up, because it's just one side. Let me check my board, because I might have janked something up. Hold on. That might be better. Oh, yeah. Yeah, that's looking way better. I forgot. It's always going to look right on the thing because I have a compressor on. So it's always going to look pretty decent. And I think now I can turn. Yeah. This isn't peaking anymore. So we can turn that up a touch. That's peaking. We can turn this up a touch. We can turn this down. That one's still peaking a touch. La la la. Now they're both peaking. Cool. Okay, let me turn it down just a little more on the board. BRB. And then we'll get to it. Daniel Rodriguez says hello. Hello, Daniel. Okay, hopefully that's just not like totally brick walled now. That looks a little quiet, but just continue adjusting that from this side. La 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 la. Test, test, test. Test, test, test. Test, test. Test, test. Test, test, test. Test, test. Test, test. Whatever. As long as you can hear me. All right, back to it. So, actually, sorry, I gotta grab that FTDI. Then back to it. All right, okay. So the FTDI comes directly from the test board I was building for the Fujimoto, the 6502 trainer board. So I'm just going to steal it. And that's the story here. And I need a pair of scissors. Or wait, no. Just desolder it, you frickin' something offensive to myself. Wareham says, test is fine. Grazie. Yeah. I will say, well, my iron is heating up, which, you know, it's already almost entirely heated up, but I do need to pull. I could start from scratch, but do need to pull some code. It will be easier. For, as I said, I already have code both for the bitbanging. Here, everybody can guess my password to my private local GOGS instance. Yeah, I just moved this over from my MacBook. So this is a fun thing. So firstly, I have the assembly for, it's really gross because I was messing around with it and didn't clean it up. But this was the assembly for my Bitbang serial routines for the trainer board that we're going to steal. And the one thing about this, I think I actually, yeah, I already updated the values, so that's, so I don't get to show you my my heuristic cycle figuring out thing, but I guess I'll go through this code in a minute. But down here, I've got this receive wait routine, and so it just, you know, chucks number in Y and then loops until Y is 0. And I did this for the trainer board. I got so freaking sick of, well, not sick of. So what I would do is I would build this, put it on the trainer board, see if the serial worked, see that it didn't work, and then have to adjust my weight number. I was doing cycle counting, but apparently like I'm really bad at it. So I just kept adjusting this number, and it was taking forever. And I eventually got it zhuzhed out, but that was for my prototype board. And so for the final ones, the prototype board I was running at 3 megahertz, I think. And then the final ones, I'm running at 5. And so I needed to readjust everything. And I thought, like, okay, I'll just do it proportionally, should be fine. And, like, that was not working because I am a fool. But, so what I ended up doing and what this code is, but apparently I don't have to use it because I did commit the version that I already pre-calculated. But there's this super neat... I mean, there are a ton of, open source 6502 emulator cores because they're really easy to implement, and the 6502 is very well known. So anyway, it's a header library is the one I found. I wanna credit the person because it's cool. Flu, if you're out there, good shit, man. This was very useful. So I was just able to slap this in, and it is, I don't know if it says in here, but it is a cycle-stepped emulator, which is what I needed, because now I can run this and run my ROM code in it, and I can write code that will chuck out how many cycles there were between, for example, like for calculating this, samples to the I/O port that I am using for my RX pin. So that was how I ended up doing that, because then I could do the change the number rebuild cycle, but it was way faster. So there you go. That's that. That's what this was. And also I'm making a little simulator for the trainer board, which is kind of how this started. But I mean, the trainer board is so simple. The complicated bit really is that I'm doing Bitbang serial on it, and like to develop software without having to program in the bootloader sequence and whatnot. Having a little simulator would be nice, but it's Bitbang serial, so I have to do, like, checking so many cycles. Like, I have to do reverse Bitbang on the other end in this code. So, like, the structure of the thing is basically the 6502 core and an array for memory. But then there's this. So it's interesting. Anyway, that is way beside the point. The point is my iron should be toasty now, and... Well, we will still have to adjust this assembly for the bitbanging because uses a different port, uses a different pin on the port, all that good stuff. So we'll have to adjust that slightly, but our speed should stay pretty much the same. So, ooh, I might have to recalculate because fun thing about the 6502 has rotate instructions. But they don't take an argument of how many positions to rotate. So you just have to call the instruction once for every position that you want to rotate your bits. So if I have to rotate more or less to get the bit in the position that I want, that may mess with the timing, and we may need to recalculate. So there you go. We may need this. Anyway, the iron is ready. So let's start by doing the minimal amount of hardware stuff we need to for this, and I'll get the NES window out of the way. But come on. OBS. Select the thing. My mouse is over. Also, we should crack a beer, because beer, good times, great oldies. Yes. Let us desolder this thingy and resolder it to this pin, I think. I think that one. And then double check, and then put our Bitbang routines in our ROM. Maybe do something fun like... I was trying not to overcomplicate this, but do some fun way of like being able to either have it boot right into the ROM monitor or just immediately try and wait for data to come in on the serial and load it and execute it, so that like I can just hit reset, maybe with like a keyboard button pressed down or something, and immediately have it attempt to boot off serial so that we can have real fast cycles. I don't know. We'll see. Beer was about to foam out of control. thankfully I was relatively smart and put headers on this thing. But the fun thing about this breakout board, thank you SparkFun, is yeah, they did not put the header holes that are on the back edge here on the same spacings as the ones that are on the side here. No reason for that, no technical reason that they wouldn't be able to do that, and yet they did. So, like, you can either put headers along the side or you can put headers on the back. If you were interfacing with headers on like another homemade, that's not the word I'm looking for, but another custom made board, then sure. But like, you can't, like, the proto boards that I use are on a 1/10 of an inch spacing, so I can't put headers there. Anyway, that's fun. Doesn't matter because I don't think I will need anything except for TX going into here. Right, I think. Yes. And then, let's see. I mean, literally, I guess just hook up the ground. Like, all I need is a jumper wire if things are right. 2 jumper wires. 1, hook up ground. 2, hook up TX to my arbitrary pin here, and like, we should be in business, I think. That's ground. And I don't know what color to use for transmit. Well, I guess it's not going to matter because I need to find a wire of the correct gender. There we go. It's white, apparently. We're going with white. And again, I think TX, because I think this is labeled what is coming out of the FTDI. I don't know. We will find out. Okay. So, I mean, like, we should be good to go because the monitor is in there. Okay, I'll boot this thing. We will see if it's trying to do floppy stuff from last time, in which case I will need to just rebuild it to have it jump right into the Monodora. But let's just find out. Yeah, it's going right into the floppy code. And there's no floppy plugged in, so that's gonna not be a great time for you, NES. So let us move over here. This should be a quick change. Like I said, just don't even do the floppy stuff. We will skip straight to the part where it goes to the monitor. I am scrolling the wrong way because I've been using a Mac a lot lately. There we go. That's the correct address. Excuse me. The correct direction. Init stuff, and init APU, sure, and then remove. Jump. Init, yes. Write it. And build it. And wait a second. And pop out our ROM, I suppose. And pop in our ROM, I suppose. And open our programmer. And still set to the EEPROM. Excellent. Load. Yes. Correct offset. Yes. Okay. Yes. Write it. Go for it. Okay. So, if I am not a complete idiot, which, you know, it remains to be seen, Partial idiot, I know, 100%. Complete idiot, you know, I'll give myself the benefit of the doubt. I will. I think that differs from day to day. Oh, power on. There we go. There's our prompt. So now, let us really quick. One thing that I'm forgetting is, of course, every time I should like write these down on a post-it note and put them on my desk. In fact, I could. I have post-it notes. But like, you think I will? Probably not. Anyway, right. Register locations. I need the one that has the drive presence thing in it. Registers. It's the digital input register, right? Digital input register. DIR, 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 DIR. Yes, bit 7. Yes. Yes. So let us wait. I didn't look at like what what register that was, but it's bit 7 of DIR, which is the 7th register. So let us, and now I have to remember the syntax again, of the very monitor that I wrote into this thing. It's the address, so that's just going to be 8007. Oh, that freaking key. Okay, that's fine. That's totally fine. What we need to do here is something. Right, the hack that I did last time, which was start at 8006, set it, dump it, and then dump 7. And does that seem correct? I don't know. The way we can find out is, as usual, ground the RX pin, do the same thing, 8006, and yes. And I need to remember that it is inverted, which is also potentially going to have an effect on our Bitbang code, but not by too much. I think it'll just change the type of branch, which won't even change the cycle count, because I am... No, I'm not using bit. I think I'm just using a straight up and. I don't know. I'll have to look at it. I haven't looked at that code in a while. But that was right. I just need to remember that's inverted. Good shit. Transmit. DIR. RX. TX. Okie doke. And really, I should have had this plugged in this whole time. I know I have a OOSP here. Yes, I do. It is right here. But I think I am potentially out of OOSPs. Oh, wait, no. My monitor is plugged in, and my monitor has OOSPs. This should work. I've turned off my monitor. There we go. Okie doke. Let's see if this blows everything up. No, that is a micro beat. Frickin' frack. This requires a mini B. Doop. What is the resting state of TX is supposed to be high, right? Because what's it? Thingamajiggy. Start bit. That's what I'm looking for. Start bit is low, so it should be high, unless it's just not set to anything because it's not, you know, open. The port, I mean. But let us check really quick. 8.6, doop. Did I totally bone the NES? Just make sure. Okay, I was just making sure ground was where I thought it was. Because it's either this row of pins or this row of pins, and I was afraid that I had just wired VCC to. Bad thing. But no, I think we're good. Okie dokie. So, 8006. Oh, shit. Keyboard's not working. Interesting. Is it because of that? It is. Oh, that's fun and annoying. What? What? I should only have their grounds strapped together. Wait. Oh yeah, that's ground. And I have... Oh god, sorry, I'm just... Why do I feel... No, yeah, okay, there's a VCC pin on here. That's what I was using to feed VCC into my tester board. So, I was just making sure I wasn't, again, feeding VCC into this thing somehow. So... Oh my god, I think I had ground plugged into the wrong thing. That... could do it. Okay, 1, 2, 3, TX. There we go. Seems fine. Don't worry about it. Plug this in, make sure it doesn't break. Nothing is connected except for TX and ground, so it should be fine. No. It really fucked everything up. Wait. Oh, is that my weird break issues that I've been having? Okay. We're all plugged in. This looks good. Yes, that seems reasonable, because if TX is high, which I would expect it to be, then the result should be low on this side. So that looks neato burrito. Cool. So I think we're pretty much ready to go. I'm trying to decide whether or not I want to go a safe route and do like some DTR or CTS toggling on that wire, just to make sure things are getting through the proper way, but I'm kind of feeling like just friggin' grip it and rip it. Christian Iverson says, wonder if there were any basic cartridges for it, kind of like Master System had. Yeah, 100%. There is, if you go look for it, there was a thing called Audience Help Me, Famicom Basic. So, yeah. This is just for fun. I haven't done this in a while, that bears repeating. Alright, so it's pretty much 100% software from here on out, folks. And what I think I am going to do is... Let's just start by... I will put the Bitbang code in here. I will adjust it to match... No, I'll adjust... Okay, I'll adjust the Bitbang code first. Yeah, let me pull down the sources for the simulator, adjust the Bitbang code so that it makes, so that it's reading from 8006 and checking bit 8 and using inverted values because it's an inverted input, and make sure the cycle timing is right. Then I will shove it into the actual source on the ROM, and I think for starters we can just like write some code that sits there and get chars from the Bitbang, and then writes the character to the screen if it gets one, and then we'll know we're good to go, and then we can use that to write a really simple ass client bootloadery thing. So software side, let's go. Please switch to the correct screen. There we go. Also, Worm said, read a bit of, well, I don't know if it's read or read. Dirk Gently by Douglas Adams. So I propose a video title. It's just a PC, a holistic approach to programming the NES. Never read anything but Hitchhiker's Guide. So, as far as books, I've never read a single book except for Hitchhiker's Guide. I know the name Dirk Gently, and I actually, like, it doesn't register to me that that was Douglas Adams, so that's an interesting fact for me today. Okay, let's pull this source, VS Code, do something crazy like open a new folder. We'll also have the fun of writing some more C# because, you know what I found out? Never wrote... Yeah, this will be a fun story while I'm getting this set up. I have never written serial port software in .NET, even though I am, you know, a .NET developer by trade. And so I had to write, you know, a little bootloadery stub host program for the 6500 tutor, and so I did it in C# because, of course, and also because I figured then you can mostly run it anywhere with how flexible .NET is these days, and it's a damn nice library. I really have to say. And the fun thing is, with it being .NET, you can also access your serial ports from PowerShell very trivially, which amused me to no end. But I mean, I guess you can do anything in PowerShell, really. It's kind of a full-fat language, even though it's very fucking weird. What am I doing? I am git cloning. What is the heck is the address of my server? HTTP, blah, 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 192.168.1.211, port 3000, jmarlin, 6502 sim. Okay, so we got this. Now the question is, do I have a Windows C compiler? No, of course not. What shall I do? Do I have Sigwin on here? Doesn't look like it. One would have thought that I have a C compiler on here. I'm trying to think of the best way to go. Because clearly I guess I need to install something, which is honestly kind of shocking. I guess I could install like I could install MingW. I could install like Visual Studio Community Edition. What is going to be the fastest frickin' thing here? What do y'all think? Christian Iverson says MingW, so I'll probably do MingW. Wareham said, dude, Dirk Gently's Holistic Detective Agency, it's totally worth a read. It's a detective, alien, ghosts, murder case, so much fun to read. You know, it's like, I don't know, I don't even register Douglas Adams as, like, having written anything but Hitchhiker's Guide, so I will have to. I really will. I like him, I like me some Terry Pratchett. So I will be down. Alright, let's get MingW. Fine. MingW, W64. Downloads. Or I could just install a Linux VM. You know, whatever. W64 dev kit? Is that a good... What's... There's a lot of different things here. I haven't, like, just installed straight up MingW in... ever? I don't know. LLVM MingW seems good. Yes? Nobody says anything, so I'm just gonna... LLVM MingW, MinGW, I've never been sure on that. Is a toolchain built with Clang, blah, 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 targeting x86 ARM ARch64 with releases both for running as a cross compiler for Linux and for running Windows. Supports address center. Blah, 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 blah. Let's get the one with the MSC runtime, x86-64. Ooh, on another side note while I'm doing this, so again, I bought, been a little while now, but I bought one of the M1 MacBook Pros when I had a little extra bonus money, and it was a very nice treat to myself. Really love that laptop. But one of the coolest things about it now is that I have not messed with, I like this. There's a huge group of people for whom this will not be at all shocking, but I finally decided to install Windows 7 for ARM, or Windows 11 for ARM on QEMU, and holy shit, it's good. I was really hoping it would be insane, not like between the absolute cojones on the MacBook and how good the x86 emulation seems to be on Windows 11 now. I was hoping I could like run some halfway decent Steam games, and I tried Portal 2, and I was getting like a couple frames a second. But it seems like older games, and mostly I want to play like the stuff off GOG that they don't have, Mac packaged up versions for. Seemed to run great. I was running Rayman 2. It was amazing. Anyway, do recommend. It's like I can do any of my Windows stuff, basically full speed. It's very nice. And at this point, I'm considering just straight up what I'm using right now. What I'm streaming on it's a Xeon workstation that I am holding for a friend that I have swapped out the hard drive on, and like it's nothing crazy. He bought it secondhand off eBay, so it's not amazing. It's a HP Z something. But I kind of have it mostly here. I mean, like it's a dedicated streaming machine, so it has that going for it. And it has some beef to it, but it's also like I don't have any other dedicated Windows boxes. Not that I need to do this streaming with Windows. That's kind of arbitrary. But at this point, I'm thinking like just freaking get rid of it and use my MacBook for the streaming too. The only thing is, well, this is the thing, and I was just thinking this earlier, and then I thought to myself, Sparkle Cam, which I use for the DSLR, because this washed out bokeh thing is very important. I bought a Sparkle Cam license for like $60, and like that's not crazy, but like I would like to still use this camera, and that would be a pain in the butt if I either had to buy it again. I don't know if they have a Mac version or whatever. But I bet theoretically I could pass it straight through USB and like host it inside of the Windows VM. Would be cool. And then I can just do everything on the Mac, and that would be amazing. It's amazing how long this is taking. I said, it's not a beast. I think you can tell. Christian Iverson said, I just used the W64 flavor with M32, but it won't work on XP or older. Well, I don't plan on using XP or older. But thanks for the tippage. And Wereworm says, the Netflix show is also good and it has nothing to do with the book besides the characters, so you can watch it without spoiling the book just to see if you like the style. I like that. Maybe I shall. You said Netflix? Yes. Okay. This is thrilling. Okay, but all I should need to do is throw this in my path and get me gone, right? 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 There we go. Okay. straight up bin folder. Oh, which is AR64 for some reason. And there's i6. Okay, so do I just ignore everything in the root? Apparently that's ARch. And what? Boy, did I just waste all of my time on this? Oh wait, does this contain all of the bins? Yes, it does. Okay. Oh! These are cross compilers. I'm dumb. Because they're .exe files. So the AR64 is the compiler for AR64. That makes sense. And okay. So I guess let's try throwing this in my path and seeing what it do. Where am I trying to go? Here we go. Echo env path. Okay, that is correct. Just making sure that I am remembering the right things. And then can I just do env path, blah, 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 env path plus 2, all of that. Maybe I hope. Echo path. All right. Now, what do I have available in here? I have a lot of binaries. Seeing if there's like any handy aliases so that I don't have to frickin' type out the whole name of the frickin' compiler. But I think I probably will. Oh wait, no. CC, sick, or Clang, all of these, right? Because they are probably all just links to the same thing. So if I do CC, sick. All right. And because of the way this is set up, all I should need to do is do CC show 6502 sim.exe main.c sick, and that is going to crash because I didn't put a ROM file in, which is what I expect. I also need to build my ROM file, which is probably that's it. That's a sh. That's a shell script. Basash. Man, really? I thought that MingW comes with bash. Oh, there's also gcc.exe. Nice. Not that it matters. Yeah, I mean, I guess it doesn't. But whatever, because I should, I mean, it's just 2 commands, so I should just be able to literally copy that into a PS1 and call it good. Copy build.sh build.ps1. Did it do stuff? There's a rom.bin. Okay, so the way that this was written currently, I give it the ROM file, and there you go. So it gives me cycle, so a tick is a cycle here. But yeah, so this just tells me every time that that port is sampled. And this timing should be roughly correct, but it's not going to be exactly correct because, again, we need to update the code to match what we got going on here. So, what am I opening? Code. Where is my code folder? Why am I blind? It's right here. 6502 sim. Open it right up. Yes, I trust the authors. Do I, though? Do I truly trust this author? rom.s is what we're looking for. And for our purposes... Actually, I have this in a Git repo now, so I can just delete pretty much anything I want. So I set up the stack, which is whatever. None of this I really care about. Yeah, none of this I really care about. But let me double check the simulator code really quick because I might be able to get away with, well, I was going to say get away with changing what address this is sensitive to. So on the trainer board, I have my user port at 8000. And that may be close enough that I don't actually need to recompile this if it will detect like 8006 as being in the same range, because all I need to check is how often it tries to read that port. Okay, so my hack here was I'm using the top bit here of the user register temporarily tell the update routine that it was sampled. So, and that is if A14 equals A15, which is, or no, if A14 doesn't equal A15, which is the case at all of the, like everything from 8000 to whatever, 32K worth of space. So that should be fine. I don't think I need to change a thing. I guess the first thing we can double check is if I go back to the ROM and I update these all to 8006. Really? No way, that's the only look. Yeah, why didn't... Oh, because $sign is a regex thing. 8,000. 8,000, so... Replace with 6. Replace with 6. Replace with 6. I should have just find replace this whole thing, but... Too bad! And if we build it, they shall come... Cool, same thing. Brilliant. So, for my purposes, I am going to get rid of everything that is not Bitbang read. I suppose I could do a block select first. Okie dokie. There we go. And we're implementing bitchar. Blah, 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 blah. Right, so load A8006, and my bit is no longer at, what is that? Or my TX is no longer at bit 5? 5. So I need to change that to 80. Yeah. And that's fine, that's fine. Do that. Okay, so we load the register value, we back up the value in Y. Why are we doing pull A? When did we push that? Oh, okay, so we put a 0 on the stack here. Then we are pulling it. Oh, because I think that's our value in flight. Yes. Okay, so this is the thing on the stack is our value in flight. Then we do a logical shift right. Y. Oh, because we're shifting in this way. And right, so literally it's just update that to 80. We might not even need to update the cycle count at all. So we check to see if the bit is set. If it is, oh, so this is the part that we actually need to back or swap around. So this I think we can just switch to a branch if equal, right? If it's going to be the opposite logic. And that, again, should be the exact same cycle count. But then what was this about? So we ORed the accumulator, which is the thing we pulled off the stack, which is the thing being built, with 80. But why was I doing that? Why? Seriously, why was I doing that? Oh! God, what a moron. I don't know if anybody got that before me, but what I'm doing is because I shifted right, then we check to see if the value that we just sampled from the TX line is set or not set. And if it is, then... So, like, I could make this code... Sorry, let me finish my thought. I have a tendency to do that. What it was doing was sampling the TX line. If it was not set, then skipping over this, because the logical shift right is going to put a 0 at the beginning. So if there wasn't a bit on the line when we sampled it, then we don't set it to 1, which is what the ORA is about. We jump over that, and otherwise we let it stay at 0. So technically, I could make this more efficient since we're pulling in bit 8 or bit 7, and that would just go right in that location. So like we could just AND that value and then OR that value directly in, but I'd rather modify this code as little as possible. So anyway, then we push the value that we're building, and then we decrease the bit the bit count, and if it hasn't zeroed out, then we wait for another sampling period. And at the very end, we have a bunch of receive waits, because that was the thing I did go over. There is a couple of... Maybe I'll go over this whole code, huh? Now that I've checked the part that I need to change, because I think that was all that I need to change. So the way it works, and of course, the reason that I did this at all, and the reason that I had the idea of bit banging on the trainer board, was because Ben Eater did his thing on doing Bitbang serial on his 6502 trainer thingy. And I was like, oh, that's a great idea. That'll help me simplify my board. So that's why it's even here, which should be surprising to no one. But for those who want me to spell it out, the way this works is it sits here, like I said, it initializes by pushing a 0 onto the stack, because that's going to be the ultimate value that we're building. Then there's this wait start loop. What it does is it reads the port, checks to see if TX is high, which I need to actually change this now, because this will be branch if equal, because what you're waiting for is for the line to go low. That indicates that a bit is going to start coming. That's your start bit. Goes low, so since it's going to be read backwards on here, I actually need to wait for it to go high. So we invert that. But anyway, that's what goes on in here, and if it wasn't, then we just jump back to the top of this loop. Then, and this is what I need to get to in a second here, we jump to this receive wait subroutine, which just waits for a bit. It waits for half of a bit period. We're assuming we're going with 9600 baud here, because that's the kind of the standard that everything defaults to across the board. So why not? Might be able to make it a little faster. Whatever. Probably not on here. Probably not significantly enough for it to work well. Anyway, so we wait for that to go low, then we wait for half a bit period, and then we go into another loop. We load 8 into X just as a counter, because we're going to have 8 bits that we read. And then what we do is at the top of this loop, we wait 2 more half-bit times. And what that does is we detected that the line went low, presumably right about at the beginning of the line going low, right? So if we want to sample right in the middle of that bit time, we wait for the line to go low, then we wait half a bit time. So like if the bit time is this. We sampled it here, or we found out that it went low here. So then, if the end is over at the other end of the frame here. Now we waited till the middle of that thing. And so you can, this is kind of like if you look at it as a timeline, this is like our cursor going through the timeline. So, boop, then it moves forward to here. It waits until this point. Then it waits another half, which puts it at the end of that start bit. And then it waits another half, and now we're in the middle of the next bit time. So this is the one that gets us halfway through the start bit. Then when we start this loop, we get to the end of the start bit, and then we get into the middle of the first actual proper bit that's coming in. So that's what that's doing, if you don't already know how this kind of thing works. And I'm also kind of glossing over how RS-232 even works in the first place, but whoops, sorry. Go look at Ben Eater's video. Right, so anyway, now that we've done our waits, and time-wise, we should be in the middle of the first proper bit, or the next bit to be sampled. We read the port again, check the bit that we care about, whatever's hooked up to TX, and let's see. I wonder if this is redundant. Oh no, it's not, because for the compare. But anyway, so we AND it and then toss the value into Y for later remembering, because what we're going to do now is, now we're back into the code we were just looking at. We pull the working value off the stack, we shift it to the right, then we check to see if that value that we just ANDed was high or low, whatever we just sampled off of the TX line, and then we make a decision whether to set that high bit that's coming in to high or low based on what was on the line. Again, I just made it backwards because of this. And then, now that we've done that, we push it back onto the stack, check to see if X, we count down X, see if we're at the end of the loop, and if not, we do that whole thing over again 8 times. Then again, we're back here. The receive waits, to kind of, they're really just there so that we don't start sampling again. Like if we had a tight loop of get byte calls, it might start it might read the first, what is currently the stop bit at the end of what's being transferred, assume that it's a start bit and start sampling, and then we're totally off. So we jam some in there just so that that's not possible. Then we pull the result off the stack and return it. And then we can delete send wait here because we're not doing any sending. Not that it matters, because I'll be moving this source over to the other file anyway. But now we're at that receive wait thing, which, again, I didn't actually have to change any of this code, so this timing should be correct. 13 loops is what I determined to be empirically the correct amount for, half of a bit time at 9600 baud. But yeah, all it does is loads 13 into Y, that's how many times to loop, then decrements it, checks to see if it's 0, if not, blah, 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 loops, and finally returns. So this should be pretty much good to go and slap into our code. What I need to do is just double check that this is correct. So let us build it again. And you see it is broken. Oh, you know why? It's because the simulator simulates the line going low. Or, it's always low, so it always thinks a byte is being transferred, is how the simulation works. So let us actually set this to... oh, this is going to be some shit, because I'm using that byte to for a hack. Okay, here's what we're going to do. So let's set this to 80, and I will just swap things around. So that... yeah, instead of using that bit, I will use the low bit for indicating, hey, we had a sample, FYI. And then that got sent into this update peripherals thing, and it checks that byte, which is actually that byte now. Then it clears it, which is actually that byte now. Okay, that's why that's doing that. So let us rebuild. Everything should be fine. There really shouldn't be any change, but being thorough. Oh, because my path is not set here. Now it's set. Okay. Now we run it again, and it's 183 again. And let us do the math. 183 should be right, but let's be sure. Let's use the calculator on Google because I don't know. Sure. 9600. And of course, what we're seeing is since it waits, just to be clear, this 183 ticks is 2 cycles. Actually, if I scroll up, you'll see. Oh Lord, just raise this because this scroller sucks. Scroller, there's a word. Yeah, so see how it's 30 ticks, which is just the code starting up, then 244, then 183. So this is just, again, the CPU starting up, and then it immediately detects that the line is low, and then 244 is 150% of 183, which is because this is 3 weights, because it's that 1 half weight, and then 1 full weight, and then everything after that is 1 full weight. Right, because it's always those 2 weights before it does the sampling. So anyway, 183 times the reciprocal of our clock speed on the NES should be equivalent to 1/9600, which is 1 bit time at 9600 baud. So 1/9600 is a little over a millisecond, and 1 over. Let's see, because this is in my search history. Okay, so NTSC NES runs at 1.79 megahertz. So we divide the cycles that it took by that, and that'll tell us how many seconds each sampling period was. And clearly this should already be right because this was that. So it's 1.02 milliseconds, which is way close enough to 1.04, which is what we were seeing. So that should be golden. Again, don't need to change a thing. This code, I believe, is right. We're going to find out in a second. But that's that. So now I can steal this, and let me clean it up a touch and get it up to the standards of our NES ROM code so far. So firstly, let me remove all these cycle times, and then I'll make everything all caps because that's what I decided to do for some reason. And I want to at least be that consistent, you know? What about... Let's do this. Percent %S, look for semicolon, then any number of numbers, at least 1 or more, followed by the end of the line, and replace it with nothing. There we go. Genius. I wonder if there's a way to capitalize everything, too. I don't know. Delete, 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 delete. Those don't matter to us. This also doesn't matter. Now we just get the core of our code. So let me just go through and capitalize everything because I'm a psycho. Okay, get. I'm gonna call this get serial. LEA. PHA. Wait. Start. LDA. LDS. Yes. We're all about the LDS here. Mormon programming, you know, that's what this channel's into, bro. JSR, LDX, next bit, JSR. Oh, I should be updating these two. Wait, start. wait. Receive wait. JSR. Receive wait. LDA. And TAY. BLA. LSR. CBY. BEQ. No bit. Or A. No bit. Push A. Decrement X. Branch if not equal. Next bit. JSR. Receive wait. Pull A. Return. Return to sender, which is what I'm going to continue calling it. I can type. Replace. Semicolon. There we go. Receive wait. Load Y13. R wait Y. Decrease Y. Branch if not equal. R wait Y. RTS. Bam. Alright. Grab it all. Jam it into our code. Write a test. Be excited if it works first try. So I could just throw this anywhere, I suppose. Let me throw it right after the flop code. Okay, here's the floppy code. Blah, blah, blah. Seek, seek, seek. Select, blah. Read sector, blah. Read sector, blah. Read sector, blah. Do, 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 do. I have had half a beer. It's not the beer, I'm just insane. That's what I'm saying to y'all. And in a second, I'm going to pause and drink a good amount of beer and maybe some Diet Coke. Take a quick break, read some chat. Okay, it's in there. Now, back to the top. And entry. Gotta skip over all this crap again. Do. Okay. And I can leave that for now, no reason not to. But this is going to be test read from Bitbang serial. And literally all I'm going to do is, I don't know, read and print, and it will just be JSR, whatever I just called that, get serial. Get serial. And then what is the name of my thing? Put? No. This is going to be another JSR, but what did I call this? Print. What did I call it? Oh, wait, it was like Percher. There we go. So literally, and Percher expects the character to be an A, so this should be all we need to do to glue these together. Literally this. And I think we're set. Hopefully. And what this should do is just keep sitting there and wait to get a byte off serial, and then when it gets a byte off serial, print the byte as an ASCII character, and then do it again. Oh, except I need to do this part. Fuck it, I'm just writing a jump. Read and print. Are you excited? I'm excited. That was a whole bunch of work for really what amounts to not much. Plugging in 2 wires and some Bitbang serial, but I feel good about this. this off. Looks like it built. That makes me happy. Pull this out. Doody-doo. Put it in the thing. Doo-doo-doo. The classic hits. You gotta give the people the classic hits. Okay. Back over here. Doo-doo-doo. Load up the shit. Doo-doo-doo. Load some stuff from that disk. Basic.bin. Offset 1. 10,000 hex. Get the hiccups. Blah-de-blah. Program the thingy. Doo-doo-doo. Drink some beer. Mm-mm-mm. Be successful. All right. Okay, so the other thing I guess I need to do is, like, connect to the FTDI. Might be a good call. Should I just, like, get TerraTerm? What should I do? What should I do? I guess I'll just get TerraTerm. I could also write some C# because it's so very easy. Oh! You know what I can do? Just to be an absolute freaking dork. Let's do this. Let's freaking do this. PowerShell. My man. Increase the font size, I suppose. Okay, you know what? What am I doing? Just use VS Code. I'm already here. Alright, so what we need to do... I can't remember if it's already included. Let's see. System.io.ports.serial port. Bam. You don't even need to import anything. So there's COM4. That's our deal. And literally just new COM4. Probably should have assigned that to something. There we go. And port dot parity is defaults to none. Let's see. Stop bits is 1. Oh, okay. So port dot. There should be a thing for port speed. 9600. Told you, it's the default. Anyway, everywhere. So, port open, and then let's make writer equals new system equals system.io dot stream writer new from port. Base. Or wait, no, I think the port itself might implement stream. Yes, it does. And now, if I do this, should be writer dot write. Can I just do this? Apparently, that's a thing. So, are you ready to boot an NES and do crazy shit? I think I'm just sleepy. I don't know what's going on. Let us go over here. Let us power this on. I think the ROM is not plugged in right. Oops. That looks better. Okay, here we go. Do I have... Oh, okay, that's... Not really, what's the word? Correct. That's not really correct. Interesting. I wonder if that's just noise? I have no idea. I'm not sending anything. FYI. Well, this is just weird. Like, it should be doing something. Hum. Maybe. Reading that port can't be as fast as I thought it could. Seems strange, but I don't know. I don't know. Do you know? I don't know. Lots of garbage. Lots of garbage. Let me tell you what. Whole bunch of garbage. Huh. Worm says the NES Ouija board. Correct. Okay. That's funky. I guess we have to do some debugging. Good. Always good. Sorry, just thinking if there's anything obvious that I'm missing. One thing that I can kind of do just for sanity testing. No, this isn't really going to work. Wait, it could. What I'm trying to think is just debug that it's actually receiving a byte. Boy, I need my my host download interface in order to debug my host download interface. So what do I want to do here? What did I want to do? Let's just do port close, just because. So what I'm actually going to do is, instead of trying to print the value, I am going to just print something, because the way that wait loop works is that it waits for a start bit to happen. So anytime a start bit happens, it will just go on autopilot, sample 8 samples, and then return. So I can at least tell that it tried to read a character if I, instead of calling percher here, I'm just always going to load a, let's just do an exclamation point, and yeah, I'm just going to do that. And that way, now it should print an exclamation point every time it sees a start bit. Get through all this bullshit, build it again. Oh, that is definitely not how you write that. Load a literal exclamation point right. Try it again. Okay, are you ready to burn another ROM? Are you? I sure am. It's in there. Load it up. Offset 10,000. Okay, program. What I'm going to do for now is I'm going to leave this dangling. I'm just going to hit power, and this has a... Oh. Huh. Wait. This could be interesting. Am I not inverting it? Oh. Qua? So... grounding this is having 0 effect. Because I thought this was had like a pull-up on it, but am I wrong? So let us try tying it to VCC, and it also doesn't stop when I do that. So am I sampling the wrong bit position? Let me see. Power off. So with this tied to VCC, oh, powers being pooped on through to the NES. That's what's going on there. Interesting. This is what I get for plugging shit in that way. I would have thought that would work though. Just VCC straight into this thing. I don't know. Maybe I'm still breaking shit in some silly way. But like they're on the same ground, so their relative VCCs should be the same. Maybe I should just find a VCC over here. That's funky. Yeah, I guess it's just feeding VCC down here and giving the NES just enough juice to run, which is weird. So I should attach this to an NES VCC. Where's the best place to do this? Where is the best place to do this? Here's what I'll do. Get a double mail, assuming I have one. Which, of course, is going to be the last one I find. Oh my god, seriously? I just need a double mail. Yeah, that'll work, whatever. Yeah. Do that, plug that into that, and then I can just poke VCC. Which is going to be this pin on here. So, yeah, that should not be doing that. And if I, on the flip side, connect it to ground, which would really be any of these, so it doesn't matter. So I'm almost definitely sampling the wrong bit, which is... How the frick am I doing that? Okay, back to the code, my lovelies. Back to the code. There we go. Which, I mean, would explain the garbage. But that's still kind of weird. Cereal, get cereal. So it's 8006. No, it's not. It's 8007. That's why. Because I had 8006 in my head because when I was testing in the monitor before, I had to type in 8006 because of my frickin' 7-key bouncing issue. That's why. That was totally the wrong register. Well, that should be easy. Let me get this hooked back up to TX. There we go. Yeah, oddly TX won't backfeed this thing. Which TX should be at 5 volts right now. Probably, maybe it just can't source enough current to drive the whole thing? Could be. Anyway, that's linked up. Let's get the thing, put it in the thing, and do the thing. Unplug this thing and put it in the other thing. Now that's in the thing, so let's go over to the thing. And at that thing, we shall do the thing, if I can remember my keyboard shortcuts. We'll load it up, just like we did before. Set it up at the offset that we did the same time before. Hit OK. Hit program. Then we go and program. And now we are going to program the thing. Okay. Alright. Okay. This better frickin' work this time. Or else I'll eat my own face. Now that would get the views. Okay. So, we should have no exclamation points. None. Beautiful. Now, let us get the desktop on here. There's my... It definitely... Whoever called it last time that it's definitely my syscall interface acting up. It definitely is. Okay. Here we go. Back to the most powerful of shells. Let's make that port again. And then port open. Defaults work fine. writer. Wait, it took a shit. Why are you taking a shit? What were you shitting about, my friend? What? What? What did I do? Sorry, you probably can't see what's going on here. Yes. Port, yes. Port dot open. Yes. Oh, because it's already open. Okay, I'm just gonna really quickly. I didn't see that was going insane too. Let's try this. Port. Wait, let me list the ports just to make sure I'm not. Okay, still COM4. Make a port from COM4. Open the port. Access to COM4 is not. Why? What? Why? The fuck? Why is access to COM4 denied? Okay, I'm just going to close this whole PowerShell because I think that object is still in existence. And I just need to kill everything. Okay, let's try this again. Port is new system IO ports serial port new COM4. Oh, and the coolest thing is on .NET, of course, this library works perfectly well on Mac OS, on Linux, on everything, which is pretty great. Port open. Which, I mean, you know, like Python does too. Same div. But I am a .NET nerd, so. Okay, now. Writer is a new... No. Is a system IO stream writer. From port. Now, writer. Write. A... And it didn't do anything. Do I have to flush it or something? Writer flush. Okay, that also did nothing. I mean, things may still be screwed up. For example, I just unplugged this from TX and nothing happened. Okay, so now it's waiting forever. So things are still not happy. Everyone said, "Hello from the other side." Very much so. Because you know, if it's an NES Ouija board, then the other side is death. Okay, I'm sure that's what Adele was singing about, right? Okay, so now has come the time to review the code and see what we're doing dumb. So firstly, let me double check that goddamn port. It was 8007, right? Right? Yeah? Yes? Yes? Yeah? Losing my mind. Oh, right. I want to look at this doc. It is digital input register. Read from register 7. Yes. Okay. So that's the right register. Load A0. Push A. Load A from that register. And with 80. And it's a little insane because one way or the other. Here, let me actually really quickly, just to make sure it's not something totally wild. I'm going to do the same test that I did before. Just actually touching this directly to VCC and making sure that, because for all I know, the TX line is stuck at ground. Anyway, one or the other should do something. Okay, cool. So now the possibility is, okay, I'm back to feeling lucky. So what I'm doing here is I'm just touching this to a grounded thing. It's probably broke for the same reasons as always, because I have not gotten rid of the break command implementation thing. But I'm just sitting here and grounding this, and so it thinks constant bits are coming in as long as it's grounded, because it sees a start bit. So that's good. What I'm thinking here is that I am just accidentally plugged into that TX is like the TX for the actual client circuit that you're building here, which, yeah, that's believable. So let's try RX. So, RX. Let's see, it's right position ground, CTS, VCC, TX, RX. So let us do that. All right, I still have my PowerShell crap going on over here. And let us try writing an A again. And it still doesn't work. Very good. Flushing did nothing. Interesting. Neither one. Neither one. At all. But so it's something about my FTDI then. Fascinating. Huh. I'm losing my mind. Shadate. Okay, now we're back around to, this is getting weird enough, because things always do, that I am going to hook a thing to, I don't know, CTS? Sure, let's do CTS. And thereby, here, I can use this because it already has solder on it. And so you can manually toggle CTS on and off, which is very useful. But so for this, that'd be great, because I can make sure that like the software end of things over here, all of this COM4 bullshit is actually doing something, because at this point, like, that is legitimately my wonder. Okay, so that's soldered to CTS, and I'm going to unplug this and plug it over here and reset. Very good. I'm going to do a full power cycle. And CTS should be high. So over here, it's tiny, so you're probably just going to have to trust what I'm saying, but I am going to do port dot no, CTS, wait, no, CTS is the wrong one. Whoops. We want CTS is from here to here. You can't see what my hand is doing. From the hardware to the computer. I want DTR. Which is, of course, on the goddamn header. You nonce. months. Could have just done this the whole time. Okay, so there we go. Now if I do DTR enable, these are also inverted signals, so if I enable DTR, it grounds it. So DTR enable equals true, and it didn't do anything. So yeah, that kind of confirms that, as I thought, for some freaking reason, I'm not actually interacting, like this FTDI isn't doing anything. Let me use a good old-fashioned LED. And instead of running that into the NES, I am going to literally just connect this LED to DTR. Come on, brother. Okay, so let's put that somewhere where we can see it. LED is on. Which would be the right thing, because the last thing I did was DTR enable is false. So if I do DTR enable equals true, yeah, see, that didn't do anything. Why? Why? Yeah, that's the right thing. Dear Windows, what the shit? Let me close all of the Visual Studio stuff. Like maybe that's not the port. Maybe it's actually not detecting it properly. I don't know. Unplugging it completely, plugging it back in. Like maybe COM4 is some other port. And that's just not enumerating for some reason. That might be the case, actually. I think FTDI drivers are installed on Windows, but wait. You know how I can easily find this out? Firstly, by increasing my font. Hey, PowerShell. What happened to the title bar right-click menu? Properties. Font. Set it to friggin' huge. Yeah, sure. There. Now you can see it. Yeah, let's do system. IO. Ports. Serial port. It is not plugged in right now. Dot. Get port names. Yep. I need to install the FTDI drivers. There we go. Mystery solved. I thought I had already done that on this machine. FTDI drivers. That is the one annoying thing about FTDI chips. There are other chips that just like have built-in drivers in Windows. FTDIs have always been kind of weird with that. Windows 10. Installer is here. I guess I can switch back to the desktop proper. Oh, Werewolf was saying some stuff. Let us see what Werewolf was thinking. I would guess it's a ground issue, but with only 2 connections, it's hard to believe. Beat meter time. Wrong COM port. You nailed it. You got there. All right, I have finished beer 1, so let us attempt to finish this Coke, because I am falling asleep. Okay, so if that worked, plug this in now. Don't tell me I need to reboot this thing. Or is it something weird, like, because it's on a... Because it's on a hub? It's not working? Let me try that, actually. Because it is, like, when I plugged it in, it's not even like it gave me a device not recognized thing, so that's a little suspect. Alright, plugged in directly now. There we go, COM9. We're in business. And now... Doop. It's on. I have to do all this freaking stuff over again. Sorry. Port. And I should check my phone because I think my wife is texting me. So let me do that first. She's important. Okay. She's just letting me know to be quiet because she is putting the baby down. ASMR time. Worm said, isn't it funny how with computers the most simple tasks turn into a half-hour debugging session? Funny is a word. But yeah, no, 100%. I mean, I don't know if you've noticed, but that's like 50% of these streams. So I'm glad I nipped this in the bud relatively early. Port is system IO. Ports. Serial. Port. New COM9. Beautiful. Port dot open. Port dot DTR enable equals true, and there we go. There we fucking go. Flass. Beautiful. A beauty. A real Bobby Dazzler, as they say. Alright. Let's plug that into the NES. Get things going. Get back on track. Ground to ground. And yeah, we're going to stick with DTR going to my receive pin because we just want to make sure it's roughly working first. Okay, so nothing, because right now that's high. I last set it to false. So now, if I set this to every time. Well, next time I write that ROM, I'm gonna turn that off. Okay. Okay. DTR enable is true. Yay. DTR enable is false. There you go. Okay, now I bet you money. This is actually going to kind of start working. All right, I'm going to go back to TX because that's how logical naming should be. And let's try this friggin' thing again. All right, writer equals system IO stream writer new using port and writer dot write some arbitrary thing, and okay, let's try RX. And do something, you bastard. Wait, let's try flush again. Writer dot flush. What the living shit, dude? Literally, how? clearly using the right port now. Zero bytes to be written. Not in a break. CD holding is not a thing. And I mean, it shouldn't be using handshaking anyway, so. Okay. This was my hope. I think it just hung itself again. Okay. Let's try from the top. Oh, interesting. Okay. It's still being a little silly, but that was promising. Okay. It's all fucky, but I think we're getting somewhere. Yes. Okay. So, big issue is that this thing is still freaking flaky as shit, but let's update this so that it actually prints the goddamn character, because I think things are hooked up right now. The driver is actually right now. We're getting closer. Pull the ROM while we're here. That is what we're going to do, my dear. Alright, so let's open Visual Studio Code again. And I am going to add a few more weight stop bit weights, because I don't know if it's because of the general flakiness of this thing, or if it's because, like, when we were getting like multiple exclamation points for a second there, wondering if potentially that's not because because the thingy is Oh, because it's... I was going to say because it's starting to sample the next value when it's not done sending it yet, and the line might still be low. But that doesn't make any sense because we're doing the print character after that, and that is going to take up a bunch of time, so that, no, that wouldn't make any sense. So yeah, let us just go to the end of this thing and totally frickin' disable. Oh no, that kind of needs to be there. Let's go to IRQ, BRK, handle. And we will just immediately return from this. We're complete, blah, 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 blah. RTI. Testing. Remove someday. I don't know. Probably not ever end up using this for anything, but RTI. There we go. Now, let us look for... Can't remember what I named that loop. Let's just do get serial. There we go. Instead of printing an exclamation, now we're going to go ahead and print the character. Are we feeling lucky? Are we, punk? I don't know. But it's worth a try. So let's build this shit. Link.ps1. Okie doke. Now, let us program it. Back. Load. There's the thing. Offset it a bit. Hit OK. Hit program. Program up this thing. Okay. So now we can officially say if the flakiness comes on back, then it wasn't solely that break handler, but could be partially that I was trying to do the break handler. I don't know. Let us see. Did I close that PowerShell? That would have been silly. No. Okay. Cool. Ah, see? The flakiness. It is not just the brake handler. Interesting to know. Tell me, is 47.7? Well, writing 48 also prints 7. This thing is so damnably flaky. So it seems like, yeah, it's still not entirely working. Let's try using the writer, because the writer should still work. Maybe. It's like, it got worse. Hey, look, a random... That's probably a bot. Good for you. Yeah, the writer just, like, totally doesn't freaking work, which is actually really bizarre. Hey. Oh, but this is really going to be a problem because... But look at that. It's actually, I mean, that's worth something. But we need to get this flakiness under control because if we're going to try and send a payload and it craps out in the middle of it, that's not going to be helpful. But let's try one cool thing. Because I think there is a overload for this for strings. Alright, that kind of worked. It's too fast. It's actually really interesting. Does it just write the first thing in the string? One second. Does this work? For each write post. Will that iterate the characters? Let's try this. No, that does not iterate the characters. Annoying. Well, what else can I do? Because there's port write line. Yes, there is. I'm sure this isn't working. Oh, it is working. Okay, so at this point, I'm guessing it's just too slow. Oh, yeah, probably because the time to print the character, because of the screen blanking interval wait, is so friggin' long, it's probably missing all of the rest of the stuff. So that's a whole nother thing, is pacing. Yeah, Wareworm actually literally just called it. You're on it, bro. Should we just get rid of that? Because the thing I can't remember is... I mean, if we're not going to print stuff, it doesn't really matter. When we're loading code, it would be really nice to have some kind of... I'm kind of... Sorry, one second. Can I kick this person? Okay. I feel bad if that was a real person just being odd, but... anyway. Doody-doody-doody-doo. Sorry, I'm just trying to think. Because we could do like a buffer as well, but that's overcomplicated. And at the end of the day... I don't know. I don't know. All I want to do is print hello world. So let's just do it one by one. Let's do this. H E L L O O space W O R L D. Gotta put an exclamation mark on there, 100%. And then for each port dot write the thing, and then system threading thread sleep for 1 millisecond. Heyo world. That kind of worked. Is 1 millisecond still not long enough? Okay. There we go. There we go. That's all I wanted. Kind of. Still not quite there. There you go. Don't tell me I never did nothing. Worm said, if you use putty, you can set a delay. Yeah, because I mean, most things you can set a pacing delay, which I mean, honestly, that's probably the right thing to do. Because if you use something like putty, you can just like drop in a file to do a raw transfer on and set the pacing to be whatever. That might be the way to go. I mean, is it? I guess I can. I mean, it's like I can set if I'm going to write a small program to do it. I can also just set my pacing there. Literally just thread sleep 30 milliseconds. So we might do that because I do, like I said, I do want to see feedback on the screen so that I at least know that I'm receiving the data that I wish to be receiving. Or some data, you know. So yeah, let's move on to that part of things. How long have I been going? 2 hours, not bad. Because we're actually very close. Where said it's like Usagi's Hello World. Dave would agree with you. He can't stop making references to Hello World. Right. So, let us now, instead of doing this, let us consume bytes. I think I'll just do a simple thing like first 2 bytes set the count. Yes. Yes. Because that should be easy. I guess I'm gonna start. Sorry, I hate this because the difficulty of loading stuff into code on a 6502 is the pages. And I want to make this easy. So regardless, I'm going to start at a page boundary because that makes life easy. Like, we'll always just load to a fixed address. We could do this as like a 2-stage thing too. But I'm trying to think, do I send a 16-bit payload size and then be able to send more than one page, which is, for people who don't know 6502 stuff, a page is 256 bytes. Do I send... Right, so do I send 16 bits so that I can load in more than a single page of data? Another option, because the thing is, because you, when you're writing your data, I mean, there's several ways you could write the code, but generally the 6502 does support indexed memory addressing modes, so that you can just like increment the X or Y register and then write to an address offset by that register, and it makes the code fairly nice. But because those registers can only hold up to 256, if you want to roll over to the next page, you have to put in some logic to handle that. Which is, it's not the end of the world. It's not even that hard. It's just a little extra complication I don't want to deal with right now because I want to make this super duper simple. So the other, because I was going to say the other option is I send like a number of pages count, and I just always send a multiple of some number of pages and pad things. Because that might not be so bad, because then I just need to have an outer loop that does a page counter and then read 256 bytes. And then at the outside of the loop, I'd need to like set an address in 0 page, which also isn't so bad. I mean, the other option is even like, it doesn't have to be multiples of pages, because if I'm doing that, then I might as well just I can put an address, a 16-bit address, in 0 page, and then you can do indirect addressing, so that you say, 0 page value 3 contains your address, and then at the end of every loop, go through, grab that address, do a 16-byte add, on it to add one byte, and then really you could do arbitrary. Like you don't have the problems of indexing where like it's easiest to start at a page boundary, because what I can just do is just write the address to that location. Or so I can, sorry, I left out a thing I was thinking, is that as part of the protocol, I can send the address that I want to start writing to in the payload, and then the logic will literally just take those, stash them at that 0-page location, and then do the loop that I just described using that spot, which doesn't give a single fuck about paging, because it uses a full 16-bit address indirectly. That might be the way to go. I think that might be the easiest way to go, while also being the most flexible. And then the most complex part about that is just doing a 16-bit add, which literally it's just you do your add on the low byte, and then if it carries, you also do an add on the high byte, and that's it. Yeah. Let's do that. And in fact, because of the way that ADC works, you don't even have to. You just clear carry, add 1 to the low one, then add 0 to the high one, and if there was a carry, it will carry. It will carry in. So let's do this. This shouldn't be too bad, now that I've thought it through. So we need to start by allocating a 0-page spot for that address. Oh my god, I keep scrolling the wrong way. I really do like the macOS scrolling direction now. I know I can invert it. You know how lazy I am. Okay, 0-page thingies. Alright, so let us start clean at let's call this serial load. Address is at 20, nice and clean. And then instead of loading and printing, we can actually go back to you know what's interesting is I might be able to steal one of the CMON routines, because it has routines for printing hex values. So we could print the actual hex values. Let me see about that. CMON's all the way at the bottom. Floppy code, here we go. Bloody blah. Bloody blah. Ah, that's a lot of fucking floppy code, dude. Okay, yeah, here's the CMON stuff. Dump byte. Let's see, so load Y0, load A. Oh, addresses the current CMON address pointer. Yeah, we actually could hijack this. Let's just hijack the CMON address thing. Let's just use that, because why not? It's already that, and what we can do is, since dump byte already just does an indirect access of this pointer, and then prints what's there, what we can do is we can get a byte, then since we're using that address pointer location, it will literally already be pointing to the byte we just read. Call dump byte. Problem is it jumps to M2, which is jumps back into the monitor. That's some garbage. Okay, well then, never mind that plan. That would have been really sexy if it worked, but no, because this jumps back into the monitor. So instead, let's use out hex, which I believe, since that does load A, yeah, so that would work the way that I was just thinking. So instead, we, and in fact, let me, ooh, do we just dive into it and assume? Well, it's a subroutine, so it's good to use. But my question of, like, does it do any formatting? Does it print some spaces? I don't know. But I think we can use it directly. So let us go down to where it was saying, or where our code was. Skip all this bullshit. And what we will do, I'm going to call this serial boot. And we will get serial. Then we will JSR out hex. Beautiful. Then don't need to do that. Then this is my other question about going whole hog, is should I stop here, test this, or should I just start implementing? I'm just going to start implementing. Okay, so yeah, let's just do it easy this way. I love using the stack, so I'm going to keep doing that. So we'll get the value, push it onto the stack, print it, pull it back off the stack, just in case out hex messes with the value, which it probably does. Then we shall do something. Store A, and it's going to be the same thing that they did, where it's going to be load Y, a literal 0, and then store A to there, because I think that's the only, I think on 6502s you have to, it's always Y indexed if you want to do that indirect load or store. But so we store the A value, and then we shall, now we have to do the increment part. So we will do clear carry, load a, wait, no, what am I doing? Sorry. What we actually wanted to do, right, because we need to, the part we're doing right now is actually writing the address. And we should probably check for the end too, like the end address to stop at, if we're going to do the whole thing. So, right. So let's read a byte. I could put this in a little routine. Fuck it, let's put it in a little routine. It's going to make this a little cleaner to write. So let's make a routine. We're going to call it terrible name, but there you go. And so that will do the get serial, push A, print it, pull it, and then RTS. Cool. So now it will be JSR get and print, and then take it and put it in the serial load address, and then JSR get and print, and store it at serial load address plus. So we will send that in the same endianness as the CPU, which is not necessary. We could really do it however we want, but it doesn't matter. So that's what I'm doing. And then, so that will set that address And then trying to determine the best way to do the counting and getting to the end, and determining when we're done. I think here's what I'll actually do. I am just going to use address. Address. Oh, because it only has one D. All right. Address. And then actually I will go back and I will switch out. I'm going to recall this, rename this serial end address. And what we will do is trying to decide if we should do this logic on this side or on the sending program side. But what I'm going to do is literally store the last address in there. And then every loop will just increment and... Well, I want it to be the last byte, not the byte after the last byte. So we'll compare the 2 bytes to each other. So the current address, high and low, and the expected end address, high and low, and bail if they match. Then, if they don't match, increment the other one. But I can't decide if I want to do the calculation on this. I feel like it makes more sense to send how many bytes we want to send, rather than the end address. So I'm gonna have this code calculated. Yeah. So we get the address. That's where we're at right now. And then the next thing will be to get the count. How do I want to do this? It's the add and carry math that always gets with me. The logic of that math. So let's do another JSR, get and print. Then what we'll do is now we have what will be the low end address, or what? No, the low count, and then let's add that to the low address, and then store that at low value. So the other thing is I need to make sure I remember that there was a carry. If there was a carry. So, get and print, then add with carry. Let's make sure we clear the carry. Add with carry. Yes. Literally using that address. So that means take the thing that's at that address. Not the address, not what that address points to, but actually what is at that location. And we're going to add that incoming thing to it. And now there will be a carry if that did carry. So oh, that's how you do it. Well, that's got to be how you do it. So now if there is a carry, it'll still be sitting in there, so you can just ADC 0, like I was saying. Wait, no. That's the whole thing. This is what throws me. It's because you have to load the value, because it's a... and actually, I'm going to have to store this, so... and now I've lost the carry value, which is the part that confuses me. Anyway. Can I do some fun stuff using X and Y? I don't know. So here's the thing: is I'd need to like stash whether there was a carry, and then do some stuff, and then get back to that. Hey, looking at chat. Hey, Trey's here. Tricks are for devs. Wareroom says, I really wonder where the random behavior comes from. I was so sure it was from the interrupt, but now I'm totally puzzled by this. Yeah. I don't know. I assume it's just like flaky connections and shit. I don't know. Maybe it's gone. Maybe the thing that we saw the one time was actually nothing after I had removed the brake handler stuff. Maybe we're lucky. Because it sat there for a long time and didn't... when I was doing my Hello World test, it sat there for a long time and didn't ever do that, so... Who knows? I'm ignoring it for now. Alright, okay. Come on, 6502 programming geniuses, and help me out here. This shouldn't really be that hard, and yet my brain is melting. Yeah, you know what? So, if I transfer this value into y, I don't think that will upset the carry flag, will it? Maybe that's the trick. Where is my... just open another instruction set reference. 6502 instruction set reference. Thank you, mass work every time. And then we were looking for... Why did I do that? Control F. T-A-Y. Here it is. Let's look it up. It affects the negative flag and the 0 flag and none of the other flags. So I think that's the way. So add with carry, what was an address, stash it in Y, and then we still have the carry flag, so but we have to God, I'm so bad at 6502 assembly. Yeah, so let me rethink this. So I'm actually thinking at this point. What's going to make my life easier is let's send them the other way around. Let's send them big endian. And so we're going to expect the size is big endian 2. And what we're going to do is I'm going to receive the big end, and then I'm going to stash it in X. Or no, I'm just going to push it. Which actually might be an option for the other, well, yeah, anyway, I'm going to push it, and then I am going to just immediately get the next bit, right? Or byte. Get the little end. Then we do this. Clear carry, add the little end to the low part of the address. Which is still going to be stored little endian, right? Then take the value, stash it in Y. I was only thinking because I don't want to do this in the middle of this because it might screw up my value in Y. Though I could just first disconnect of the night. It's been a while. Whoopsie whoopsie. Anyway, yes. Stash it in Y. Then again, this is so overcomplicated. So freaking overcomplicated. Then pull the big end off the stack. And since we should still have the carry in the carry, and pull also doesn't affect that, I believe. That's why I was saying I could probably use it. I could probably use it for either. Yeah, no, that only affects negative and 0. So, same thing. pull that off the stack, then just do an ADC, because our carry is still there, and do an ADC with... well, actually, you know what? Story doesn't... I think this is why I was overcomplicating this for myself, is for some reason I was thinking story would affect the flag, but it's not. Yeah, story doesn't affect any flags, you freaking moron. I don't know why. So that was what was screwing me up, because I was like, I have to stash it, and that's going to throw off my flags, and I'll lose the carry. No, it won't. It will not. You're a maniac. You're a maniac. Back to your regularly scheduled programming. So let us do that the way you're supposed to do it. So I'm undo everything that I just said. Sticking to Little Endian. And I will still... With this, I think... Because I still have to receive the values. So... I will still throw it on the stack. Right? Yeah. Yeah. So I will have the little end on the stack. Sorry, it's this subroutine that complicates everything. Now I have the big end on the stack. And this can, calling this can potentially screw up my carry flag. So, actually I will, the one thing that I will do is stick to, I will send Big Endian. I will yeah, I will push the big end onto the stack. Then I will get the little end, clear carry, add, and now that's the one thing, is now I can immediately store it at address, which is not a symbol. The symbol is address. Right. And then I can immediately pull the big end and then just add it to address +1. And then just immediately store it to address +1. Yes. Right? Yes. Is this reasonable? Is this logical? Oh, yeah. So, Trey said, what are we doing, Bitbanging serial? And, I don't know what star at Trey Dempsey is supposed to mean by Wereworm, but, yeah. So, sorry, you missed the fun of we already implemented Bitbang serial, and it's just for reading, because, this was the whole thing I was kind of talking about it last time. To increase the cycle of the try something with the floppy, it doesn't work, burn a new ROM, as I've been told a bajillion times since the beginning, is we're using Bitbang serial to poop code into the NES so that we can serial boot it, hopefully relatively quickly, and have a little bit faster turnaround times with the test cycle, maybe, is the idea. But anyway, right. So now I'm building the actual like bootloader part. Okay, so we get the address, blah blah blah. We get the count, blah blah blah. Oh right, this is actually we want to add it to the address value, but we want to store it into whatever we were calling this. Serial end address. And this will do the same thing, address +1, but then we'll store it to serial end address. So address will be the actual field that we're incrementing. Serial end address is going to be what we're comparing to see if we got to the end. So this will be the part. We send 2 bytes for where we want to put the incoming data. Big endian. Then we send the number of bytes that we want to send. Big endian. We calculate the end address and stash it. And then we will go into our let's call this serial boot read next. Good as anything. So we'll do another JSR, get and print, and we will do, what do we do? So we just get a byte, we store it at, let's make sure Y is clear, load Y, literal 0, and then store whatever we just got from get and print to the location pointed to by address. Okay, so that's the meat and potatoes of it. Then the next part is to check to see if we're at the last spot, which is literally just load a let's load a address, compare to serial end address, range not equal to serial boot increment. But if they did match, then we got to check the high part too, so same thing. Load a address +1, compare it to serial end address +1, and if they match, we'll branch if they are equal to, I don't know, let's call it serial boot enter. And finally, they didn't match, so we do the add. So we will, let's see. Yeah, we can't guarantee what's in A. So we will load address into A again, and then we will clear carry, add with carry a literal 01, and store it back to address. Our carry is still in the flags register, which I was reminding myself of moments ago. So that means that we can load A also will not affect that carry address or that carry flag. So load A address +1, and then we can just do add with carry literal 0. And if there was a carry flag in there, it will carry over here. And then we store that at address +1. And finally, we jump back to serial boot read next. Yep, and the one spot that I forgot was we didn't do, yeah, so serial boot increment, that label needs to be set. That would be here. Serial boot increment. So now I can actually jump ahead to this. And then, so normally it jumps up to the top at the end of here, but if this happened, if the end address and the current address were the same, then we go to serial boot enter, serial boot enter. Where things get interesting, which just occurred to me now, is there Is there a indirect jump? Because I need to jump to the address that we have in the 0 page. And if there's not an indirect jump, we can't do that. Good, there we go, sweet. I thought there was. And I'm assuming you can only use the 0 page for that. Well, yeah, because it says it's 3 bytes, so 3 bytes. Okay, nope, that's not. So that's not a 0 page. That's because this wouldn't be either, because the operand in this case is a 2-byte literal immediate address, and so that would be the same case here, right? It doesn't matter at all, but that makes our life easier because I can just do jump address, or not address. Oh, there's a pisser. Okay, we need to rewrite this to not do the compare thing, actually, because we lose where our entry address is, and then we just have 2 memory locations that are exactly the same. So, frick. There are 2 things we can do. We can either duplicate that value, which would mean that I have to rewrite less of this code, or we can rewrite this code, which is, let's just do that. So what I'll actually do instead is we'll just do a countdown to 0, which is, I should be able to use, I believe, subtract with carry in the same way as add with carry does here, which just means I need to, instead of adding the address and the size, I just stash the size, and I will count that down. Ooh, fudge. But that doesn't... God damn it. That doesn't change the issue of... thinking. That doesn't change the issue of having things destroyed and not being able to find the original address again. Or... Processing. Okay, here's a hack that I think I can do on this real quick. You know what we're going to do? Is we will calculate serial end address. Oh, sorry, right. It doesn't solve the issue of I still need an indirect address to write to. So that needs to be updated regardless. Or we find some other mechanism of figuring out the address to write to. I could potentially... I mean, the more I look at this, the more I'm thinking, like, just fuck it. Just use another 0 page value. It's like the easiest thing to do. Because sorry, I was thinking, ooh, one clever thing could be, the clever hack I was thinking of doing was decrement serial end address instead of incrementing address, and then exit when serial end address and address are equal, except it's going to be the other way around because instead of address incrementing. But then we have, again, like, we don't have... We'd be writing from the end to the beginning if we use serial end address as the address to write to, and address is never changing, so we can't use address as the address to write to. So the more I think about it, just make a new 0 page thingy, stash the address. Don't kill yourself. Let's call it serial entry address. Put that at 22. And then we will close our file because we have fat fingers. Oh, where was my assembly file? Basic.assembly. Okay. And then all we have to do is, I don't have to change a thing about my code, except for when we read the address in the first place, just store twice. Serial boot, serial entry address +1, and store serial entry address. Yes. Let me also double check. I actually have all the space I need for address. Yeah, okay. I figured I did, but I just wanted to, it struck me that I hadn't checked that. So now that that value is always going to hold the original address value, we can just jump to it. So serial entry address, and that is that. Groovy? Is that groovy? Or is it not groovy? And then I'm thinking, if this isn't completely insane, I also am going to kind of export going to export the print character function, and by that I mean I'm just going to I guess put a pointer to it at a known location. I think I can do that. I think this will make sense. So what I'm going to do is skip these tables, skip the 5,000 command do nothings, and ignore this whole fucking chunk of code that we're not using. Oh, no, the reason I was going to the end was, you foolish man, right before vectors. Is the best way to do this? I don't know. What I'm going to do, let's do a new segment. Segment global entries. And here, what I'm going to do is I'm just going to, this will be a fixed known location, and literally all that's going to be here is a jump to print string. And so these are going to be, like, what I'm thinking is we can have like 3 byte wide entries here instead of doing this whole IRQ break horse shit. And this way, when I send something over, I can quickly just do a JSR to this known location and print a string. Is that crazy? Okay, so that's a start. That's what that is. Now what I have to do is, in the linker configuration, set that to a known location, which I'm just going to set to just before the vectors. And then I can increase that a little bit by each. Well, you know what? Because I could put it at the top, at the beginning of ROM area, and then it can always grow down because my entry point is going to be calculated by the assembler every time, so it can move wherever. So that's a thought, because otherwise I have to keep updating the... Yeah, fuck it. I'm thinking too much. Link to config. Global entries. Global entries. Gotta line these up nice. It's one of the core things that makes your code run well. Load into PRG RAM room. Type is read only. And it. Why do we have these spaces on all of these? And it starts at. Oh, well, I guess. Yeah, I guess this is the thing, is code main could actually be switched to aligned instead of having a fixed location. We'll start this at, I guess... We'll just give ourselves some room. We'll start at FFF0. So, theoretically, if I do a JSR to FFF0, it should call print string. So that's a theory. Now, I guess I need to... For right now, I'm going to burn this code, and then we will manually send some bytes over. We will simulate this thing, and then we will try sending it with a tool with pacing. But let us just start by giving this a basic workout. Let's build it. Build it up. Build it right. Segment global entries does not exist. Really? Are you sure about that? Can they only be so big? Oh wait, did it just not build? Yes, because simple address is not defined. 213. 1D, you fool. There we go. Alright. Now we go over here. And we go. Load it up. And we go. 10,000. And we go. Okay. And we pull our things out. As should have been done some time ago. We power off the NES. Because we are no fool. We drop the chip in. We close up the thing. We go back to the right spot. We hit program. We hit program again. We hit program once more. And then we hope this works on the first try. Yeah. It's in. So let's get everything prepped. Let me go back to the most powerful of shells. And power on the NES, I think. Oh yeah, so reading back, people solving my problems for me. So Trade MC said very cool, which thank you. Trade MC said, oh, and I don't know if you would have missed Trey, and if you think that's cool and fun. It's not only serial bitbang, we're bitbanging via the drive detect pin on the floppy controller, so that I don't have to build extra hardware. Trey said, why not stash the address in 0 page, which is what I just ended up doing, so good job, Trey. You like, people should start taking bets on what I'm going to do, since I don't look at chat. when I am solving the problem in the wrong way. And Hiram said, just jump to the initial value of address. Yes, but the question was, how do I retain the initial value of address? So yeah. Again, probably written in the worst way that you could write that, but hopefully it will work, maybe. This will be a success if I run this for the first time and send it a byte and it prints out the byte that I sent it. Okay? That's my strongest hope at this point. If we get more than that, then I'll pee my pants. So it doesn't work at all, which is, not great. Oh wait, no. It should have a black screen. So port.write, and I'm sending this big endian, right? Is what I said? Or no, yeah, big endian. Most significant bytes first. Yes. So let's write to, I don't know. Oh, I should probably know where NES RAM is. Where is NES RAM? Oh, that's a big deal. I almost just wrote to an arbitrary place. I mean, it's got to be, it's the low 2K, right? It's got to be. How could it not be? NES dev memory map. CPU memory map. Yeah. Okay, yeah, it's the first 2K. That makes a huge amount of sense. So, yeah, I'm just going to use, I'm going to write to 300. It did nothing. Amazing. Beautiful. I mean, I probably should have had it print something before doing the boot loading, because I don't know if it's actually running the code, right? That's a small issue. Okay. All right. It kind of did some stuff. 33. That, I'll tell you, that sure as shit ain't right. Is this the weirdness coming back to haunt us? It kind of feels like it. Okay. This is something. So for some reason it always has a leading 3. But maybe that's on the .NET side of things. Let me make sure that this is a byte. Okay, weird. So here is the question: is that an issue in OutHex? Is that an issue in our reading? Oh, it might be an fuck balls. No, it shouldn't be. I was gonna say maybe it's an issue in OutHex because OutHex has to print a character and then print another character, and there's a delay in there. But that doesn't make any sense because we read the whole byte in before doing anything else. So, I mean, OutHex works fine in the monitor otherwise. So why would it have a particular problem here? But also, when when we were printing earlier, we haven't changed anything about the serial git code, and that was printing stuff lovely jubbly. So I have to assume it's something weird about what I'm doing via PowerShell. Because let's see. So if we write, let's try sending a character. And then it clearly falls over, which we'll have to figure out. But let's one thing at a time. So yeah, it sent 48. So it's something about this write command, which is interesting. Yeah, that works perfectly fine. Okay. What if I try writing? Oh, you bastard. Alright, so trying to send an integral value into this write function is clearly not doing what I think it's supposed to. But that's fine, because at least that tells me that it's on the host side of things. I mean, maybe I should just friggin' switch to C# and get it over with. Yeah. Let's just do that. I guess let's go to the tools directory. Tools. New folder. What shall we call this? I don't know. Loader. Actually, no. To keep with the theme, to be like injector, let's name it loader. Here, let's just go over here. And I'm going to start a project in here, and I am actually going to take just like a 3-second break. Nothing super long. I just have to run to the little men's room. All right, cd tools loader and start a new project. .NET new console. And this should be fast and easy. Using system.io.ports. And do some quick things first. Var. I should probably kill this PowerShell so that it lets this port go. Okay, var port equals. I'm going to sit here and just assume that it's going to start with port 9. So new serial port. And I actually think I might have to .NET add package system.io ports. Yeah, cool. I think that worked. Yeah, cool. It added it. One would think that this would recognize that that package was added, but let's see. Var port equals new serial port. Yeah. Whatever. Com9 and port. Oh, let's just do. I don't know if that actually works. Port. Well, no, I do know that actually works. Using var port is that. And port.open. And then the way I'm going to do this is firstly, let us add a debugging configuration for this, for VS Code. Cool. That's fine. And with the port open, I don't know, I guess I'll just do it. Console. Is that necessary? I can't remember. No, I don't think so. Console dot right line pause. And herely I can set my breakpoint, and then I can use the debug console to actually fuck with the port in C#, where I know some things slightly better. Yeah, I guess just go for it. Building. Where I've said, I was expecting you to extend the monitor with new commands for your subs, not ignoring the monitor and resetting all the time. I might. I'm just. This is proof of concept shit. Injector. What? Why do you... What? Oh. Right, because to do this, I need to actually open that folder. Son of a bitch bastard. Okay. I wish there was just like a right-click open this folder in a new window, but there is not yet. I suppose I could implement that if I were a real Giga Chad. But, lo, I am not. Fuck me. Open folder. Doody-doody-doo. Code. No. Wrong. Tools. Load order. Now we go to run, add the configuration to the proper friggin' thing this time. Then we may begin. Make sure my breakpoint's still set. It's not. Okay. Now F5 this bad boy. And we're paused. So let's just try this again. Interesting. Yeah, so there was some kind of conversion going on in PowerShell because it says cannot convert from int to string. So, yeah, clearly. But I believe this is the annoying thing is because there's not like IntelliSense in here. There might be an add-on that I'm not using, but the debug console, as far as I know, doesn't have IntelliSense. So let me check because there's definitely, let's see, MSDN, system, IO, ports, serial port, because I can use the, you know, like the libc type write. It has one of those, and just write 1 byte that way. That's I believe one of the overloads. Yes. Okay. Which is really annoying because there is a read byte command, but there's not a write byte command, which is really kind of horseshit. Yep, so it's the array of bytes to send from, then the offset into that array to start reading from, and then the count of items to send. So we should just be able to do port.write new byte. Yeah? You'd think I'd know how this works. But let's do, I don't know, 12. It doesn't matter. The offset is 0. The number of things to send is 1. Kill this. Turn this on. Thank you. Thank you so much. Which does mean, so it's slightly more of a pain in the butt. Oh yeah, you know what we can do? Here. Observe this shit. Let's do, I am going to write, here, let me make this bigger since I'm going to be sticking. I know I said I was going to take that break, and I still need to, but you know how these things go. Yeah, just make that a touch bigger since I'm going to probably have these both up for a hot minute. Okay, before I go, let me just do this. Void send, I don't know, whatever, byte value, and it will literally just do what we just did. So port.write, construct a new byte array on the fly, which has value in it, and offset 0, write 1. That's it. And now I can just write send, and we will be fine. What do you mean port may be null here? I mean, I guess if I were passing this function around, but I'm not. So don't mess with me. That was certainly the wrong button. Function F5, you psycho. Okay, now I have this nice helper, so I can just do send 12. Ooh, let's try something more exciting, like A5 wagyu. What? Fuck off. Really? Okay. One second. Let me try something weird. Because you'd think it'd be able to see the nested. Oh, because it's not a nested function here, right? Because I believe at C#, the new C#, what are they calling this? Top level modules are really funky, and I think this is actually like hoisting it to the top of the implicit static class and making it a member. I might be wrong about that, but I think that might be happening. What is this warning? No, yeah, it is a local function. Of course, because otherwise it wouldn't let me capture a port. So why isn't it in scope? What? Let me try. Okay, so I'm going to try something real silly. We're going to do... I don't know. I'm gonna make it an anonymous function and assign it to a variable because. Will that make it any better? Right, A5 wagyu. Okay, cool. So it doesn't hate that. Very strange. Very strange. I don't know why it would like this, but not. Okay. So it's still being really, 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 really funky. Which I assume is probably because of... I'm guessing that's a bug in the code. Oh my god. Stupid debugger. Here, you know what I'll do? I hate this, but I'm going to do it. Here's what I'm going to do. This is silly, but I'm going to declare a variable called toSend. I don't know, doesn't matter. Is a byte value fucking whatever. And then I'm just going to have an infinite loop and just keep doing send to send. Put a breakpoint right here. So what I can do is just keep updating the value of to send and send bytes that way. Function F5. Alright, so I'm turning this on. And it does that sometimes because, I don't know, sure. Alright, so let's do to send equals 0x A5 walk U. Fucker. I'm telling you, it's like this hardware has got to be fucked. It's gotta be, right? Oh, I send A5 and it just, I mean, I think it's a bug. I continue to think that because it's, I bet if I send A5 again, it's gonna, no, if I send A5 again, it doesn't white screen. I was thinking maybe it's just the nature of sending A5 that it makes it fuck up in a very particular way. Anyway, we're clearly sending A5. So now, to figure out potentially why I might be having a bug sending the second byte. But that's a good start. Goodish start. Okay, I'm going to take that break. I'll probably stop it at 4 hours. I really would like to have this bootloader kind of working, though. I don't know. I'll see it in a hot minute. I have returned and I am ready for more beverages. One 1 room temperature Michelob Ultra. I have a hole in my chin. Sorry. Okay, so solving the problem of, well, I'd love to solve that problem. But I'm sure I won't be able to, so. But I do feel like we have some issues, but I don't think not. F? F you too! Hopefully not enough to really screw with us. Because I'm pretty sure what's happening here is we have like some stack issue that's tossing us off into space after we send the first value. So let's figure that out. Let's figure that out. So, back to basic data set. So we do get and print. Is our stack getting messed up here? Are we not returning from this, as we would expect? Is that possible? Is outhex screwy? Worm said maybe a pull-up resistor will fix things. I believe, but from my experience, I think there's already a pull-up resistor inside of the floppy controller. And I mean, I could try it, but I doubt it. And it's sending the right values. That's not the issue. The issue is it flying off into space. So the first thing I'm going to do is, I would love to see what I'm receiving, but for now, I don't necessarily trust outhex because it's not actually part of my code. So what I'm going to do is actually, let's just use our own code, and I'm going to just print a period. And actually what I'm going to do is just reading. Yeah, let me start here. So I am going to start my debug printing testing by just doing the normal, jump to init, and then when we're in the monitor, I can check that the value actually got stored properly. But for now, we're going to switch, we're going to modify get and print to not do this, and instead to just do load A, and then printer. And then we'll try doing just one, and hopefully that will drop us right into the monitor, and I can see if it stored it properly. And actually, you know what? Okay, I know this is a lot. And my gut feeling is to change a little bit at a time and keep trying it, but the whole thing in here is that I have to keep reprogramming this stupid EEPROM. So instead of having to do that, which ironically is the thing that this code is supposed to be circumventing when it finally gets implemented, I'm going to do the whole thing without C removed, and then instead of doing the jump at the end, yeah, I'm going to just enter the monitor. Jump in it. There. Okay. So this may not work, but at the very least, if it is in fact out hex that's absolutely trashing stuff for some reason, well, we'll sure find out. I guess I'll stop this program because... Is there a console I can get to right now? Yes, okay, sweet. Yes. So I can keep that running. Wait. Nope, I killed it. Amazing. Anyway. Go back to the main directory, do a link.ps1. I did something stupid. Oh. Should probably JSR to printer. Because I feel like it's got to be out hex, because it would be so weird when we were able to just like keep printing stuff all day a minute ago, not using out hex. And the code here literally just is storing the value and then moving on. I find that surprising. So I would be surprised if it wasn't out hex. Load up the thing and put it at 10,000 hex, and I should probably also get... I switch screens like you can see anything. Take the EEPROM out and put it over here, and then we will program it soon. Don't you have no fear. Hit OK on this thing, hit program on this thing, program it up, program it up. That is what we'll do. Hello, Luis in Peru, apparently. Okay, let's see if we have any more success. Let's go back to this thing. No, it is still running. I was just confused. All right, here we go. Here we go. Here we go. Here it is. Okay. Oh. Sorry, I'm dumb. I just set the variable, I didn't run it. Okay. It got worse. Actually, I think it might be... I have encountered this issue before. Load immediate. Because otherwise it like interprets that as an address, possibly, I think. Get this EEPROM out of here. Get this EEPROM the fuck out of here. And here. Here's what I'm going to do. I am also going to go full bore, and before we do that, load a literal O JSR printer load a literal K JSR printer. That one's just for Papa. So that I at least have some indication whether it freaking started up properly. Okay, I built that, right? Let's just do it a 12th time, just to really be sure. Load, 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 at 10,000, okay. Okay, now we program away. Making sure as things progress and my brain gets fuzzier that the NES is in fact turned off. Okay. Back over here. Run. All right. Did I actually change anything besides putting in OK? No, yeah, I changed that to print a literal period, right? Is the period in our character set? Is it? I'm honestly not sure. Because it throws me that this is just like doing nothing now. Oh, well. Fun. Okay. So, it's still being insane. Neato burrito. Is it my push a pull a in the subroutine? Okay. But yeah, again, it gets that far. So is it just the fact that I have this stupid thing in a subroutine? And then it's something about this pull A is like this push A and the pull A are like totally unbalancing the stack. Is get serial unbalancing the stack? Well, that would be weird because then you'd return from it and it should already be screwed up then. But like this is literally just pushes here, pulls there, then it returns. Very strange. Very strange indeed. Okay. And Wereworm says, I just got a present for my cat, a dead bird, at 4:20 a.m. Lovely. Sorry, I'm losing it. I'm trying to figure out what to do next. Look, if it's this being in a stupid subroutine, then the other thing we can do is leave that. Instead of doing this, literally do the same thing unrolled. JSR get serial. And yeah, just unroll the whole thing. Let's just remove Let's just remove the printing from the whole thing. What if we did that? I know that's kind of wild, but what if? Yeah, what if I just go to init right here, make sure it works, make sure it always drops into the monitor. JSR init. When in doubt, fall into the monitor. This is my way. And then I'm going to, if that seems okay, I'm going to go back, pull them all out, do the same thing. It's not my favorite, but that's what I'm going to do. I also wonder if IRQs are screwing us up in some way. Because the only thing that sends us an interrupt, let me just check that really quick because I don't know. I have questions about that. It's potentially unwarranted, but IRQ. Blah, 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 blah. Is there a non-maskable IRQ too? So I'll have to double check that. Because I thought that was defaulted to off. Maybe I should double check that. But is that a thing? 6502 non-maskable interrupt. 6502 NAI? No. Yes, there is an NMI. Is there anything hooked up to NMI? Okay. Right, so NMI, that's the one that I'm worried about. It's connected to the PPU for vertical blank. But I believe that's supposed to be off, but I'm not sure I'm actually setting that anymore. Two 1-bit registers inside the PPU control the generation of NMI signals, frame timing, and access to the PPU's PPU control and PPU status registers. Change these registers as followed, regardless of whether rendering is enabled. Sorry, I'm trying to read this and it's not making sense. Okay. So there's a flag called NMI output. And what? By toggling NMI output during a vertical blank without reading PPU status, a program can cause NMI to be pulled low multiple times. I just want to turn it off, man. I just want to make sure it is turned off. Let me look at my init code, because this may be just a big nothing, but it's entry. So firstly, SEI is to disable interrupts, right? Right? 6502 SEI. Set interrupt disable status. Okay, good. So that's fine. Blue. Okay, so then PPU state. Supposedly disable interrupts and rendering. But So it's just starting at 0 at 2000 to 2001. It was at 2000 to 2001, right? Not 2001 I care about. Okay, so it's bit 7 of register 2000, and it is set to off. So, unless I'm turning them on somewhere weird, which I find very unlikely. But I'll scan really quick. And then 2001. So it doesn't even touch 2000, which is BPU control. Let me check in at APU because I'm just curious if that is doing anything silly. Just because I am going to not call in at APU. You know why? It's because that's one of the things that I've changed, that since then things have been flaky. I'm not saying that's it. I'm saying no reason to have it turned on. I'm going to keep it turned off. But I highly doubt that's what our problems are. And now back to the main thing. We already did this, so this was the meat and potatoes. We're going to do get serial, we're going to store it, and then we are going to drop into the monitor and nothing else. Pulling the thing. Also, I see there's a bunch of chat, so let me get back to that in just a second. Write the damn thing. Write it to the stuff. Back. Load. 10,000. Okay. Program. Back. Pop it out. Slap it in. Okay. I'm sending it. I'm sending it. I'm doing it. I'm sending it. Oh, it never said okay, did it? You son of a bitch bastard. And it's not dropping into the monitor. Fassa-fucking-nating. Hold on. Oh, wait. Wait. Did I not build this? I think I may have not built this. Wah! Did I really not build it? Really? Because it shouldn't. The thing is, it should not be printing a period at all right now. Because I am not calling the thing that does that. So I think I didn't build it. Y'all were watching, you should know. Sorry, I didn't. Well, you can see my hand over there. I just didn't close it. What do you mean bad pins found? Weird. Okay, alright. Please give unto me something that actually makes sense. What the fuck? What the fuck is going on? Seriously, what the shit? I am going crazy. I'm gonna look at chat for a second, because this doesn't make a goddamn lick of sense. It shouldn't be printing anything. It shouldn't be printing anything. Oh, hold up. I mean, it still shouldn't be printing anything, but let's give it a try without calling JSR in it. Yeah. Maybe not call init as a subroutine, because it's not one. I still don't know why that would screw things up too much. It should still really just jump there, and then there would be extra shit on the stack, but, like, who gives a shit? But I'll give it a fighting chance. Load. 10,000. Okay. Program. Okay. Program. Okay. Remember when I said I was going to look at chat? An obsessive. Okay, I'm gonna run this, and then I'm going to sit back and look at chat for a second. Oh, you dumbass motherfucker! Hey guys, I know what my problem is. I'm really angry that nobody is called. Let me... You know if I'm going to say something like that, I'm going to look at chat and, like, Wereworm or Trey is going to be like, hey, it's this. But I'm going to read chat and then I'm going to see if you figure out what the problem is. Because I know 100% what the problem is. And it's fucking stupid. It's really stupid. And I know what the problem is. I'm telling you. This is not a good guess. I know what it is. Right. So, last one was Wereworm and his dead bird present. So Wereworm said, turn off an NMI. Well, that would be a trick to behold. I meant turn off the V-blank. Narayan said, SEI is disabled IRQ. The only reason I double check that is because it starts with an S, which usually indicates set, and then E, which sounds like enable, and I sounds like interrupt. I would assume that is set enabled interrupt, but it's not. Wereworm said the whole point of an NMI is that it can't be turned on. I hope you get where I'm at now. Wereworm. Narayan said, technically it is set interrupt disable mask, which is confusing. I see. Yes, that is very dumb. And also Narayan said, NMI can't be prevented from happening. PPU can be told to stop sending the NMI. That's my guy. And I missed it all, but Francois said, hi, but need to sleep, it's late here. So, where it says, I have no clue. All right, I'm going to go through the source really quick. So, just scrolling up through all this initialization code, right? The entry point is here. And then it executes all this code, executes all this code for initialization, executes all that stuff. PPU initialization executes all this, initializes the keyword, prints OK, and executes this code and returns this guy. So it's not even getting to here. I'm sorry. So I don't even think things are being flaky now. I think it's just returning to whatever garbage is in memory. What a frickin' maniac. Well, there you go. That was fun. So let's undo a bunch of stuff because it was actually fine. Yeah, so we just do this, uncomment that, and then take this, and the stream audio is probably pretty low. We had things at the top where it was too loud, and I probably turned it down a little too much. And also, it is nighttime. The baby is down. I'm trying to be quiet because the baby is like right above me. So I'm trying to not be too crazy loud. So apologies, but it is what it is. But yeah, how about we just move that to, you know, I don't know. Someplace that isn't in the code path. I guess we'll put it here. That's fine. That's fine. And yeah, and that we'll keep that. So I think we're set now. So we will never actually, our code will never execute through here. And then we do what we were doing before, which is get serial, then push the value, print it, pull it, and return it. But it's not in the init code path anymore, so that's good. Where said it's as low as always. Maybe it's just that. Maybe I'm just a quiet dude. Okay. Y'all want to flash a chip again? If we do things right here, if we do them right, we will never have to flash a chip again. Wait, no, shit. Probably want to load the code I just built before hitting program. Load, offset. Offset, 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 okay. Program, 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 program. Okay. Yeah, and that solves that mystery, because even though I removed the call to that subroutine, it was still in the code path, so it didn't really matter. We're burnt. I keep getting confused because now that I'm sticking with this, I don't have to swap camera angles. And that is built into my muscle memory. So every time I finish programming, I'm like, I don't know what to do with my hands. Okay. Watch it go. That is correct. Hmm. So things aren't okay. They're just oh. Luis CV said, "I love what you do, but I don't understand much." That's fine, because you know what the thing is? Me either. Which I think you could clearly tell. I don't know why I think reseating the ROM would make things better. It's clearly running code. Huh? So I think this is like the right code path. I don't think this is a hardware issue. That's a hardware issue. Funky. Okay, let's look at the source. I'm sure I screwed something up while I was in there. Oh, it's probably fine. There's just no print chair after the K. I deleted that by accidental. So we're probably fine. Hopefully. Okay, so let's send it. Like that's some weird hardware boot up issue, but I think this is okay. So there we go. That's not great, but we had progress there for a second. Weird. Weird. But this is better. This is better. I don't know what's up with that only printing one character occasionally, but this is good, I think. Okay, so here's the real test. Where I'm said, but now the randomness is gone, hopefully. Mostly. Maybe. A little bit. Okay, sorry, I don't need to keep doing that. I want to go back to doing this in PowerShell so that I can not have to do this weird hack that I'm doing now that I know that I need to send bytes via the long form version of the write method. But I have to set it up again, so we're just going to stick with this. Anyhow, so what I'm going to do now is do, like I was going to try to, an attempted manual write of, I don't know, payload, boot payload. There we go. There are words. And then we should drop it in the monitor, and we'll see if they wrote where they were supposed to, and we'll see if it finishes the loop and actually drops into the monitor. All of that fun stuff. So I'm going to do this a slightly more sane way. And I am going to, pre-build a nice little array. And we are going to do a for each var value in values send value, but we will break before we send each value. And then values, just going to be a big old array of values. So var values is new byte array. starters, I know it's going to be... I want to load it at, let's do 300 for no good reason. And it's going to be some number of bytes long. Probably not many. And what do I want to do here? Sorry, I just let's go to the Masswork Online assembler. Write me a little hello world. So, org at 300, and then I'm going to jump to, I don't know, call it main, and then I am going to .asciz, give me an old hello world. And then balls. How do I set up? I forget how to call. Print string. It's not hard. Okay, right. So you load. Oh, right. We have a thing called string pointer. So main is going to be, hopefully it supports that .asciz. I don't know, we'll find out. So main is just going to be load a we are big endian, so this is going to be literal hex 03. No, literal hex. Actually, it will be 03 because the jump instruction is going to be 3 bytes long. So this is going to be at address 303. So load a 03, store a at, and then we know where string pointer is. String pointer is address 3. The 3s just keep on coming. So store a 3, store a 4, and then JSR, and that is FFF0, if I remember how I made that correctly. And then halt, jump halt. Will that assemble? No, of course it won't. Yeah, ASCII is not a thing. But ASCII is. Let us just be safe and put a 0 byte after that. And then we are going to rip it out of its beautiful little home. And how many bytes is this? Did it tell us how many bytes this was? Well, 8, 16, 24, 25, 26, 27, 28, 29. 29. You know what I should be doing here? This. whatever. All right, sit tight. I'm gonna take a second because I'm bad at Vim and I'm gonna do it slowly. And now we have the commas. Are we having fun? I wonder if I can. Let's see. No. You can't. I was trying to repeat an action n number of times, which is like a core Vim thing to do. However, I am bad at it, and I clearly did it wrong. So, back to the manual. Okay, what did I say the size was? It was 24, 25, 26, 27, 21. Any fool can just look at this and say 318, 319, 31A, 31B, 31C, so it's 1D long. Not to be confused with one long D. All right, that is something. So now, let's turn this friggin' thing on and cycle through these values and see what we get. Worm says, reminds me of an 8051 monitor I once wrote. It would do strange things loading the hex code until I remembered my ASCII to hex routine only worked for uppercase letters. That's the way. It's kind of weird how it only does that starting up from really cold. Anyway. F5 in this bad boy. Ugh. Stupid randomness. That was probably a result of opening the port, so yeah. Cool. I mean, that started promising. Was that the... No, that wasn't the first byte after the size was sent that it died, was it? So there's the location. There's the size. And then the first byte, and it takes a poop. So that might be a problem with the loop. Let's see if that is reliable. Restart. Worm says you wanted to check with the monitor if the values got to the RAM correctly. Yeah, but I decided I might back up here, but I decided to just go whole hog and see if the values got into the RAM correctly after the whole read in the code routine. But it looks like reset. Come on, you know this. Okay. Yeah, it looks like something weird happens on the second iteration of the loop, and that is pretty reliable. So, let's look at that. And hope that it's something really weirdly obvious. Alright. And if I step through this, and if I look at this code and it's not super obvious, then I may just insert the drop into the monitor here, but let's see. So we do a get and print, which looks like that works at least. Then we store the value. Then we check address. Yeah, I might want to check the monitor values here, or the values in the monitor here, because I'm wondering if it's something silly like this comparison code is already dropping out of here, and it's, well, no, because then it should be going to the monitor if anything. Well, anyway, let's start there. Let's start there. Bye. Yeah, just right here. Let's drop it in the monitor. Consistency. Blue. Build it. Of course, the question is, if once I get this implemented, if sending things over serial will be any faster of a process than this. Signs point to unlikely. But we're having fun. Okay, build it twice for good luck. Load. Program. All right, let's do this. Load up my code up and hit run. Let's hit go and then we'll have fun. I think that was randomness. Oh, shit. Okay. Monitor, save me now. 3. Nope. What the fudging hell? So, that's unusual. Pretty unusual. What the fuck? I'm gonna be straight with you guys. I think something is not right. I just got this feeling. Doesn't matter. Arbitrary values. Get me to the monitor. I'm just holding down the 3 key, you guys. I'm wondering if there is an error in my keyboard routine. Or if the initialization isn't happening right. That's it's unusual. I'm gonna tell you. That's not used to that. Seems what's the word? Incorrect. Seems incorrect. What the fuck was that? Jesus Christ. What the? How? 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 It's got to be like the keyboard not implemented or not like not cycling properly. I'm just trying to think through how this fucking thing works. Because even if is it the hardware somehow? Because I would bet you money, just looking at it. Thank you for dropping me immediately into the monitor. Okay, so like when I press F and I hold it down, then it works fine. It works just fine. It works perfectly fine. Oh, man. Yeah, where it says computers are perfectly predictable. Or so I have heard. Now it works fine. Let me send it some bytes. I'm curious. Because what clearly seems to be happening in that first instance, like when it says ooh and then drops into the monitor, is that it's definitely like just thinks it's reading some bytes for some reason. It's reading a bunch of grounds, possibly because like something about the FDC isn't like reset in time or reset properly, and so it's not properly reading from that register. It's just my pet theory. And so it just thinks it's being sent a giant chain of zeros and then drops into the monitor. So why should this be any different if we put in things that aren't zeros? Anyway, let's step this a few times. Send the bytes. See if the keyboard is still just taking a shit. Yes, see, it's something about that. It must be that like I'm overwriting a value in the 0 page or something. Nothing else would make sense. But what it looks like is, okay, let's try this again. Like I press down the E key. Well, that doesn't even register. Okay, it's dead. blah. Piss in a few more bytes. It has taken a poop. But I don't think that's related. Alright. If I press the E key... Okay, now it's just straight up not working again. Yay. Again, possibly because of the values that I'm writing in. Out of curiosity, let's see. Just to prove the theory, because I can't do that right now. Value equals 0. Send it. And it's hosted. Value equals 0. And it's hosted. Value equals 0. And it's hosted. Amazing. I am putting in the tweeters just to make sure the cartridge is maintaining its connection. Okay. Value equals 0. Step it. Okay. Value equals 0. Step it. Did it hang again? Yes, it did. Value equals 0. Send it. Value equals 0. Send it. Okay. Just, you know what I'm going to do? Real quick, since I have to reset this anyway. I'm going to do this test by just jamming these values in here. 0x00, 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 0x00. Run. Okay. Here's my test to prove the theory, to get to the point here, because I'm just doing stuff. If I spill all zeros into it and we get to the monitor and the keyboard's working fine, then it's definitely that I'm messing up some zero page values that are having some weird knock-on effect. But here you go. I was supposed to be hello, but I can't type. So yeah, theory proven. If I dump in all zeros, like when it starts up and thinks it's getting all zeros, keyboard's fine until it falls over sideways. You know what? Maybe it's just the space lasers. It could just be the space lasers. Oh, fuck. I didn't mean to restart. Damn it. 420, plays it. Power on. Send. Hello. It's the space lasers.
let's read from Narion, because my soul hurts. I mean, we got the Bitbang reading working, so I can be happy. It does what it says on the box. It's a 4-hour stream that got Bitbang serial into the thing. I think it's still this randomness, whatever the flipping fudge this randomness is. That is blowing up my melon. Because you saw the keyboard started working for a second there when I wrote all zeros. And then it goes to shit. Anyway, so Narion said, I have an idea you can try maybe in the next stream. You can hook up an HC05 Bluetooth to serial module so that you can communicate to it wirelessly. That's not a helpful idea, Narion. It's not that. This is the pissy thing. Is it's not the Bitbang. It's not the serial that's not working. It's everything surrounding it. Because basically I can't reliably send my shit and have this goddamn thing work. Something is going super duper haywire. Has been for a while, and it continues. Oh, it continues. Is it my wiring? Is it still something weird with the interrupts? Is it... I don't know. What I do know is that I should ask Dave if he's going to send me one of his cartridges. Because at this point, it could just be that the hardware is so fudgy and flaky. It just seems so odd, you know? So odd. All the interrupts should be turned off. We checked. So it's not like that we should be getting interrupts triggering arbitrary code. But still, for some reason, after a short period, this machine just starts going insane. Or, for example, like this, like it just stopped. I'm sending it values, doesn't care. It effed off into La La Land. It has effed off into La La Land again. So it's not like a normal, straightforward bug in the code or something. It's just random noise. Oh my god. Werewolf. You make me think. So here's the thing. Here is the thing. Remember how I was running off of that PSU? I don't know if it was mentioned on stream that I actually switched to using a different power brick. Now it would be real weird if that power brick couldn't supply enough juice to this thing. But what if I am getting little power drops? That is an interesting thought. One would think that if I were, then regular games should also be flaky. But I don't think I've tried one. I don't think I've tried one since I switched that out. If it is that, and it's just because I'm using a shitty power supply, oh, that'll be so nice. It'll be so nice. Let's pull out this Zelda. Let's plug it in. First, we have to get it to work. Come on, Zelda, you can do it. Okay. And, like, give it a second, because sometimes it takes a second. This is looking really solid so far, though. Where said, I think the power supply situation is amplified by the long cable. Oh, decent point. And the bypass caps thing isn't a crazy thought either. Oh, actually, yeah, really good point, because, like, literally just reading quickly from this ROM might be sagging the power supply since it's got all the spikes. Or, I mean, even reading from the FDC, I guess. A decent thought, a decent point. A really decent point, actually. Okay. Because yes, this is not the world's greatest power supply in the first place. In the NES. I wonder if for once in my life bypass caps are actually an issue. Okay, let us start by. I still have the funky PSU thing. Let's just see if things are any better on this guy. I should probably plug this back in if I'm going to do that. Do you boot? Power. It's a good thing. Well, wait. Oh. I just turned the PSU off. I think. No. What's going on here? Something's not working. Okay. All right. Okay. Let's see if you stay more stable. Worm says, can't be the bypass caps. There aren't any on the board. I mean, could still be a bypass cap situation. Could be like a bypass cap situation making, like, ROM reads fuck up. But it just did the thing again. But bypass caps, you say. You say bypass caps. Okay. What size do we recommend on the bypass caps? And what's my best way to do this? Because I can So, damn it! Thought I found something. I thought I found something. But it's still shit. Okay. Let me. What size do I have? Between high resistance between NES pins and the Pi. Oh, I'm not even thinking about the resistance inherent in the length of the cables. It's only odd because I didn't have any issue. So here's the thing: I didn't have any issues with the Super Mario Kart, but you know what it had in it? Big fat capacitor. It did. It did. So how's about I put a big fat... I have just capacitors sitting around. Let's try the most basic of basics. If it was working in that configuration. And literally just try strapping one between power and ground on the board. Just a nice big fat. There's no way for it to be too fat, right? Right. Small bypass caps usually have better response times. 100 nano per chip. Let me see if I have ceramics that low. Yes, I do. That is the lowest size I have. The only reason I was hemming and hawing so much is that I don't, since these aren't like well laid out, I don't have a good spot where I can do like per chip ones. I mean, I could. It's just gonna be more of a pain. I'm gonna start with. I know you are almost certainly right, but just for fun. One mic? Maybe let's just try that. I'm gonna put a one mic electrolytic across power ground on here. Just because, again, nothing has really changed about this board. What has changed really the most is this board and the fact that the Super Mario Kart had a chunky bypass cap on it. Or just it had a chunky cap on it. One mic. Wareham said, throw in a 4.7 mic tantalum and 100 nano ceramic per chip. Oh, I see what you're saying. So a 4.7 mic for the whole thing, for like bulk capacitance, and then some individual capacitance closer. Okay, so I will. If you say 4.7 is pretty good for the bulk capacitance, then I am going to do that. Oh God, I don't want to get these mixed up. All right, 4.7. Really? Huh. Caps are weird. Iron is hot. Let's see. Negative towards ground. Let me just break all my shit. That is the way I do it. Worm said, also set up a wish list for Amazon for a nice little scope and a better multimeter. Fine. there's the 4.7. Let's see if that makes a difference to us. I'm counting on you. Interesting that it seems to start up more lively. I think that's interesting. Okay, well, let's restart this. Oh, actually, before I restart this, let me... God, if that's been causing me a lot of problems lately, specifically since kind of the reboot of this whole thing. I guess that really it would just be cool. Note that it has been stable. It hasn't done anything weird in a minute. Run my tool. Okay. No, hasn't done anything because it was hung. Yes, less than C. That is a valid hex value. I got bad news. I also like how sparkly everything is, which feels like there's a problem with VRAM or something. Or VROM. I don't know, man. I might have to call it. But I also feel like maybe we have to move everything onto the board. I don't know. I don't know. This hurts. Yeah, that didn't really seem to do anything. Could be because I need bypass over here. But, like, I wasn't having these problems with Super Mario when I was using the Super Mario cartridge. I simply was not. Oh, let me make sure one thing. Just make sure I'm not super dumb. And make sure that ground and VCC are actually connected to the cartridge. As far as this band around the edge. I'm sure they are. It would be weird if they're not. Yeah, they definitely are. I don't know, man. I am close to tapping out. Close to. I'm tapping out, man. I just don't know. I do not know. Knowing, not a thing I'm doing right now. I mean, it could also be something silly and weird, like there's a signal that I'm supposed to have pulled up or pulled down. That is not. But I don't know. I simply do not. Oh, that is one thing I can answer. Narayan said, another thing, not sure if you tried it, but UART is active low signal, aka it is high when no data is sent and it is inverted. No, word. Wareham said if it was the power rail of 4.7 should have improved things. Indeed. Matt Cunningham says hi. Matt, I've been streaming for almost 5 hours now, and I'm pretty much thinking about calling it because the last literally 2 to 3 hours have been fruitless things having issues. I've got one more thing. Literally, it's the silliest thing, but hear me out here. Nope. There was some schmutz. There was some schmutz between M2 and one of the wires on the back of the board, but scraping it away did nothing. I must call it. Bummers to anybody who was watching this and spent the, wasted their time on the last 3 hours. If you're watching it live, then, you're here hanging out. We're having a good time. But if you put this video on later, I would say now, if I were going back and editing this, at the beginning I would say tune out after the first 2 hours. You don't need the last 3 hours. So that's a bummer. That's a freaking bummer. This was supposed to make life easier. And here's the thing. I'm feeling down because I'm tired, but the bulk of the thing that I wanted to implement works. We have Bitbang serial working. It's just now the thing that is finally killing us, and it's been killing us this whole time, and it's probably why, while I had the floppy working fine for a bit there, all of a sudden, I can't get it to work, is because of whatever ghost in the machine issue we're having right now. Herb says, need to get up in 2 hours anyway, so I don't know what's wrong with you. Thanks for tuning in as always. But we have to get that figured out. I don't know. It could be the long wires. I don't know. It could be a lot of things. But that's the biggest thing is that, it wasn't like this before. It was running fine before. On the Super Mario Kart, we ran it for hours. I don't even know how long at VCF, and it was running perfectly fine the whole time. It never went down or crashed in particular. I don't know. But anyway, that's enough of me saying I don't know. I am calling it, and thank you guys for tuning in. I did have fun because I haven't done one of these in a while, and it was nice to get back in. But yeah, I would really don't expect me to be too regular. I'm still trying to wrap up my holiday presents for my coworkers, and that's taking up a bunch of my time. And I'm trying to have a more well-balanced life. So I don't know. I will hop on. Wareham says the scope would help. Also, I do have a scope. It's just a crappy analog scope that wouldn't be super helpful here. I think what would potentially be real useful is using my logic analyzer. Maybe. It could at least, I could get a trait. The problem with the logic analyzer is that you have to know when to frickin' trigger it, and I don't know what's causing the fault in the first place, so I wouldn't know what to trigger on. Narayan said logic analyzer wouldn't be able to distinguish the NES's 5-volt threshold. Why do you say that? You can, logic analyzer has adjustable, well, not, it has a couple of threshold levels that you can set it at. Like, it can, Narayan says logic analyzers are 3.3 volts. I don't know where you're getting this. Mine, its default is TTL. Anyway, plus you can adjust the threshold that it triggers at, or at least there's a few settings. Narayan, maybe it's, what kind are you using? Are you using like one of those USB octopuses? Because what I have is an old ass Hewlett Packard 1663C. It's a fucking beast. Worm said Scope would tell if there was a bad connection on one of the ribbon cable contacts. How would I catch that? I guess because it would be noisy. Yeah, I guess. Narayan said CLA logic knockoff. There's your problem. I'm sure it's super useful, but yeah, mine is. It is lab equipment. That's the only nice piece of test gear I have. It's not. It's nice. It's old, but it was expensive when it was new. Okay, anyway, I'm getting out of here. And yeah, Wareham said low/noisy logic levels. That actually is a really good point. That is something that I could definitely look at with my crappy analog scope. That is